Hello, everyone. Am I audible and visible? I don't know. Let's see. Kids can hear me, can see me or not. Am I audible? Kids, do let me know. Am I audible? I know that I am not visible, but am I audible? If yes, I wanna see. Yeah, this is your Baba HSP. Kids, do let me know if I'm completely audible and visible. I want to see green hearts in the chat section. See, this much homework I have done for you. But before moving with all these things, kids, I want to see green hearts in the chat section. Do let me know, everyone, am I perfectly audible and visible? If yes, welcome, vanakkam, suswagatam, jo bole so nihal, sat sri akal, walaikum salam, assalamu alaikum, kids. Welcome, vanakkam, suswagatam. Very good. I can see your green hearts are indicating that yes, everyone can hear me, can see me. Now, my dear friends, before coming to all these things, let me tell you what's the sequence for today. The sequence for today is, it's over here, just see, name reactions distinguishing test. What I'm saying, kids, name reactions and distinguishing test, I would like to say these two things are the backbone of organic chemistry. If you know, kids, that these two things are the backbone of organic chemistry. These holds a whole lot of weightage. So, first, because this chapter is aldehyde, ketones and carboxylic acid with their derivatives. That means if I talk about NCERT, these are two chapters, aldehyde, ketones, carboxylic acid and derivatives. That means oxygen containing compounds, and the better to say carbonyl group. The chemistry of carbonyl group we will study. Means aldehyde, ketones, carboxylic acid and derivatives. First we will see the name reactions and distinguishing test, and then as usual I will let you know the preparations along with their chemical reactions. So remember that first I will deal with those reactions which are having 15 star. What do you mean by 15 star? If I say 15 star, I will give 15 star to those reactions which are very, very important. Means you should eat them, you should feel them, you should drink them. And this I am telling from the beginning. The one who is topper, all those students who are the toppers, I was telling them, you have to drink it, you have to eat it, you have to smell it, you have to feel all those reactions. To these reactions I always give 15 stars. Now, my dear friends, these reactions I will cover up and then I will let you know the preparations and then chemical properties. Now the sequence is clear. First I will tell you aldehyde, ketones name reactions, their distinguishing test, and then I will tell you carboxylic acid and derivatives. Now, if this point is clear, that first I am going to deal with, yes, I want to see the answer in the chat section. First I will deal with what? Yes, very first from all these chapters I will tell you what I want to see in the chat section. So I am going to sit in front of this laptop and I want to see whether you are going to write. Are you able to understand or not? So if yes, then write down in the chat section. I want to see the chat section, what you are writing. So if you are able to understand, then you will write in the chat section what I have told you. What I have told you, write down. Let me see whether you got it or not. I will start with aldehyde, ketones, what? What thing I will start with? Let me know in the chat section. I'm waiting. I'm sitting in front of the screen. Just do let me know what I will start with. Aldehyde ketone preparation. No, 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 no. You haven't got it. You haven't got it. Aldehyde and ketone I will start, but I will start with what? Aldehyde and ketone is okay, but I will start with what? Preparation. Everyone is writing preparation. Kids, you haven't got it. You haven't got. You haven't got. You haven't got. You haven't understood. I will start with aldehyde and ketones. First, the name reactions. Name reactions. Not the preparation. Everyone is writing preparation. No. I will tell you first the name reactions. Are you getting my point? Everyone do let me know. Name reactions. I will start with the name reactions. Before I start, I want to show you something. This is your Baba HSP. I have been teaching for the last 26 years. It's written over 26 years. Now, kids, I've done my MTech in 2004. At 1999, I'm the gold medalist in chemistry, right? MSc chemistry. That's gold medalist, okay? Then after this MSc 99, after that GRF, then GATE, and then MTech I have completed in 2004, and I've been teaching for the last 26 years. Produced number of ranks along with mass selections. So this is your Baba HSP. People call me Magical Guru for chemistry. Now kids, like, share and subscribe. And you have not smashed the like button, hit the like button. I want to see that your attendance in the form of like buttons. Now see Utsav Mahotsav, you know very well. Now get 50% off on all NEET UG subscription, valid till October 31st. Kids, use code UTSAB and see here Phoenix Masters NEET 2025 batch by Team Avengers. You know Team Avengers very well. This is your Ambika ma'am, BioQueen, Basim Bhatt sir, you know very well, and Yava sir for physics, you know very well, and this is your Baba HSP. Now at just rupees 5499, and you can apply the code HSP10, right kids? Now my dear friends, so you see this Team Avengers. Is it visible to all of you, Team Avengers? Now I would like to say Nimbus Pro Reloaded. That is for class 11th. This is also available just for 5499. Once again, I would like to say use the code. The same code, no need to tell you again and again, HSP10. HSP10 is the code to get the benefits along with mentorship. Now, kids, let's start. Let's go. Once again, I'm asking, last time I'm asking, I will start from aldehyde and ketones and aldehyde ketones preparation or the name reactions. Write down in the chat section. I'm going to start with the name reactions or preparations. First, I will tell you what. Write down in the chat section. Now let me check it out. Now let me check it out whether you are able to understand or not. Yes, kids. Now kids, fast. I want to see that now you are able to understand or not from where I am going to start. Yes, SV has written name reaction. Very good. Now you are able to understand name reactions. Yes, now you got it. Somebody is, Harshi Rajni is still writing preparation. No, name reactions. Name reaction means the backbone of that chapter. So first name reaction. Can you guess which name reaction, whenever you think about aldehyde and ketone chapter, which name reaction comes to your brain? Which name reaction comes to your brain? Oh my God, I think you have seen. Which name reaction comes to your brain? Just to let me know which name reaction comes to your brain. Whenever you talk about this chapter, which name reaction comes to your brain first? That is aldol formation and aldol condensation. Aldol formation and aldol condensation. Now kids, this is the first reaction about which I will tell you each and everything, and it will take some time. So remain cool, Sit with your pen and copy. I will first teach and then I will give you number of questions, whatever the type of questions they can ask or whatever the type of questions they have given in the previous examinations. Is it clear? Are you ready? If yes, I want to see fire in the chat section. Everyone, I want to see fire in the chat section if everyone is ready. If everyone is ready about aldol formation and condensation, I want to see fire in the chat section. Gets everyone, hey, what are you doing? What are you doing? What you're waiting for? Sit along with your pen, copy, brain, actively participate and write out in the chat section that you are ready. And if yes, I want to see some fire in the chat section. Yeah. Now, who is going to show this? Now tell me whether R, C, HO will show, there is a fight whether aldehyde will show this reaction or the ketone will show this reaction. Do let me know who will show this reaction. There is a fight in between aldehyde and ketone. Who is going to show this reaction? Hey Champa, please help me. Who will show this reaction? Whether aldehydes will show this reaction or the ketones will show this reaction. Yes, Champa, do let me know who is going to show this reaction. Aldehyde. Both can show this reaction. Whether they are aldehyde or they are ketone, this reaction can be shown by aldehyde as well as ketone. Both can show. So in this case, it is known as aldol condensation. And in that case, it is known as ketol condensation. Now, sir, if it is ketol, if it is aldol, then why aldol is more famous? Why the name is aldol? Why not the name is ketol? Kids, remember that the name of aldol is more famous because aldehydes are more reactive. These are more reactive. So their equilibrium shifts more in the forward direction, and these are less reactive. Ketones are less reactive. So their equilibrium lies mainly in backward direction. That's why aldol is more famous name. Now you got aldol is more famous. Sir, how ketones are less reactive and aldehydes are more reactive? Is there any reason or we have to cram it? No, naku. It's not looking like idiyappam muriku. It's, I will make it nalla iriku romba sulvam arpudham, right? Just wait and watch. That why aldehydes are more reactive. Just see, kids. Just see. If I write down CH3, CH double bond O, this is aldehyde, and CH3, C double bond O, this is ketone. Its name is acetaldehyde. It is being acetaldehyde, the aldehyde, acetaldehyde, and this is being acetone, the ketone, acetone. Now, my dear students, see, for aldehyde, there must be at least one hydrogen, and this group is known as carbonyl group. This is common thing that is known as carbonyl group. If on carbonyl group, at least one hydrogen is attached, that is aldehyde. If both they are carbon, that is known as ketone. Now see, this carbonyl carbon is having partial positive charge, and this methyl is donating electron through plus I. So through plus I, it is donating electron, and hydrogen's inductive effect is taken 0 on a standard scale. Now here two methyls, they are donating electron. So this carbon was hungry. Two methyls they have given, hey, eat idli, have some dosa. So its hungerness got decreased. Charge, hungerness is charge. Charge decreased too much. Here charge decreased one much, on which there is more charge. Yes, its charge is less, so reactivity is less because stability increased. Stability increased too much and reactivity decreased too much. One more parameter is valid for decreasing its reactivity. What is that? Steric hindrance. Steric hindrance on this carbonyl carbon. This is putting a steric hindrance, so the coming group can't attack easily. Steric hindrance is increased. Steric hindrance, you know, the bulkiness around the carbonyl group. Steric hindrance increased. Now steric hindrance increased, so overall its reactivity is less because one thing, the charge is less, and second thing, the steric hindrance is more. This point is clear to each and everyone. Is this point clear to each and everyone? I want to see in the chat section. First of all, do let me know, is this point clear? Keep on showing green symbol if yes, everything you are getting. I am telling you from the scratch. So aldehydes are more reactive. Remember in your brain, always keep it in your brain that aldehydes are more reactive. Aldehydes are more reactive. So they will show aldol formation easily, and that's why common name is aldol. Whether it is aldehyde or it is ketone, the common name will be, whether it is aldehyde or ketone, the common name is aldol formation. Aldol formation and condensation whether it is aldehyde or it is ketone, the common name which we will use, that is aldol formation and condensation. But what is the necessary thing required? They should have at least 2 or 1 alpha hydrogen. Just to let me know, to form aldol formation, at least they should have how many alpha hydrogen? Remember that aldol formation says at least 1 alpha hydrogen that is acidic, and 1 more alpha hydrogen is required, that is for condensation. Aldol condensation says at least 1 more alpha hydrogen, 1 alpha hydrogen. So overall, how many alpha hydrogens are required to show aldol condensation? At least how many alpha hydrogens should be there, kids? Do let me know. This is the most important point where kids are doing mistake. Always those who are droppers, dreamers, they are always making mistake at this point. At least how many alpha hydrogens are required? Remember that at least 2 alpha hydrogens that is acidic are required for aldol condensation. This point is clear. I will prove this thing when I am going to tell you the mechanism. At least 2 acidic alpha hydrogen. Now how to find out whether the alpha hydrogen is acidic or not? Let's see. First, let me tell you the thing, then I will tell you how to find out. The thing is that aldehyde or ketone, or the combination of both, or the combination of both, but what is required? Containing either of them at least 2 alpha hydrogen atoms which are acidic. When they come in contact with alkali. What type of alkali? Remember, dilute. They will form aldol. Reversible aldol. Aldol will get formed. The forward direction is known as aldol formation. And the backward direction, if aldol is breaking, that is known as retroaldol. Retroaldol. Now, how to find out what is the characteristic of aldol? How to find out this is aldol? Then remember that aldol means beta hydroxy, either aldehyde or ketone, Now, this aldol will undergo dehydration. To give aldol condensation product. That I will tell you. That I am going to tell you. Just see. That I am going to tell you. Now, once again, let me tell you. Either aldehyde or ketone plus dilute alkali, that will form aldol. What is aldol? Beta hydroxy, aldehyde or ketone. On heating, it will lose water. Water will eliminate out to give aldol condensation product. How to find out whether the product is right or wrong? That will always be alpha beta unsaturated carbonyl product. So this is the story I'm going to tell you in detail. Till now it's clear? Just to let me know in the chat section. Till now, is it okay? Kids? Everyone, just to let me know. Till now it's okay? Till now, is it okay? Till now, is it okay? I want to see in the chat section. Do let me know, kids. Till now, you are able to understand? If yes, very good. Good evening, Jyoti Jain, Pujasri Devi, Namita, Jyoti. Very good, very good. Nitisan. Okay. Okay, fantastic. Now see, kids, how to find out alpha hydrogens. Now the thing is, how to find out acidic alpha hydrogens. Just see, kids. How to find out acidic alpha hydrogens. How to find out acidic alpha hydrogen atoms. This is the point, and this we have to understand, kids. Let's see how we will get it. See kids, remember that the carbon which is sp3 hybridized and which is adjacent to this carbonyl carbonyl, this is your carbonyl carbon. Remember that this is your carbonyl carbon. And the directly attached carbon which is attached with 4 sigma bonds, 1 randa mono, 1 2 3 4 sigma bonds. 4 sigma bond means it is sp3 hybridized, 1 sigma, 2 sigma, 3 sigma, and this is the 4th sigma. And the hydrogen attached to this carbon will be alpha hydrogen and it will be acidic. No sir, I am unable to understand. Don't worry kids, don't worry, let me tell you. Suppose if I write down CO, CH2, CH3, don't worry, no fear when Baba is here. This is the compound. This is your carbonyl group. Can you see? Directly attached carbon. Directly attached carbon is this one. Directly attached carbon is that one. These carbons are known as alpha carbons. Clear? Alpha carbons. The hydrogens attached to this alpha carbon, if the carbon's hybridization is sp3, then only gets sp3. These two are sp3. So these 2 hydrogens are alpha. These 3 hydrogens are alpha. For 3 and 2, 5 hydrogen which are alpha as well as acidic. Just try to find out. If I would have written like this, just see that CH2 double bond CH, C double bond O CH3. Now see kids, this carbon is carbonyl, that's okay. This carbon is carbonyl. This carbon is attached with sigma bonds, all sigma. So this is alpha carbon. This is also alpha carbon, but this is sp2 hybridized. So this hydrogen is not acidic. This is alpha hydrogen but not acidic. This is these 3 alpha hydrogens and they are acidic. Why they are acidic? Because they are attached with sp3 carbon. This is attached with double bonded carbon. So remember that double bonded carbon, they are not having acidic hydrogen. Sir, I am unable to understand. Don't worry kids, let me tell you in detail. See kids, if I write down one compound like this, CH3, C double bond O, H, CH2 double bond C, H, C double bond O, H, CH triple bond C, C double bond O, H, CH2 double bond CH, C double bond O, CH3, CH triple bond C, C double bond O, CH2 CH3. Now I think all the points will get cleared with these 5 examples. Just see kids, everyone just see. This is your carbonyl group, fine. That side there is no carbon, so leave it. Just see on the left hand side, this carbon, it is sigma bonded. So this is sp3 hybridized. Now these 3 hydrogens are 3 alpha hydrogens and acidic. If you see this carbonyl group, that side nobody is there, no carbon is there, leave it. This side, this carbon is alpha carbon, but because it is attached with double bonds, so not acidic, not acidic. Once again see, this is carbonyl group, that side nothing, no carbon is there, but this side carbon is there, but it is sp hybridized, no acidic alpha hydrogen, there is no hydrogen. But now see, this is your carbonyl group, This is alpha carbon, that is also alpha carbon, but this is attached with double bond sp2, so not acidic, not acidic. These three are acidic, three acidic alpha hydrogen atoms. Now see in the last one, last but not the least, this is your carbonyl group. Fine. The carbon directly is attached, alpha carbon, but not having hydrogen. This carbon is alpha carbon and having two alpha hydrogen atoms which are acidic. First tell me if you are able to understand this much, then I will give one question. Do let me know in the chat section. Show me green hearts if it is clear. Show me fire if it is not clear. If it is clear, show me green hearts. If it is not clear, show me fire. I will give all the questions. Baba will give all the questions at this place only. So don't worry, kids. I will deal with all the questions. So nothing to worry, kids. Nitishan is saying Romba Sulubham. That's really fantastic. So I think this is clear to each and everyone. This is absolutely clear to each and everyone. That's fantastic. That's fantastic. Yeah, it is. Whatever I'm teaching, that is good for board exam, IIT, NEET, for all the examinations. Whatever I'm teaching today, this is 100% useful for your board exams, NEET as well as IIT for all the examinations. Now, let me ask question. Let me ask questions. Compound number of acidic alpha hydrogen atoms. You have to tell me the answer, right? Are you ready? Is everyone ready, kids? Number of acidic alpha hydrogen compound. I will write down compound. H C double bond O H. Do let me know in the chat section. For the first A1, B, CH3, CH2, CHO. The second one, CH3, 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 C double bond O, H, D, C6H5, CHO. Four compounds I have written. Do let me know the number of acidic alpha hydrogen atoms. Let me check it out in the chat section what you're writing. 0, 2, 0, okay, 0. So let's see the first compound. First compound is having 0. The second compound is having 2. The third compound is having 0. Why 0? Because this is alpha carbon. It is not containing any hydrogen. And this one, this carbon, 4 valency, so 0. If everyone agreed, do let me know in the chat section that if your answer is same as I have got. If your answer is same, then write down in the chat section that your answer is same as what I have got. Now, once again, let me tell you the compound number of acidic alpha hydrogen atoms. Then only you can understand things, kids. You are getting this point. CH3, CH2, C double bond O, CH3. A, B is C double bond O, C double bond O, and C C double bond O, C double bond O, and C double bond O? Do let me know in the chat section. I'm waiting for your answer. I'm waiting for everyone's answer, kids. Do let me know. Do let me know. Questions मैं बेटा सब कराऊंगा. I will give you all the questions. 5, very good. In the first it is 5, very good. So see the first answer, 2 and 3. 2 plus 3, 5, exactly correct. Now in this one, 2, 2 and 2. 2 plus 2 plus 2 coming out 6. Now in this, 2, 2, 2. So 2, 2, 2. Oh my god, let me check. 2 with respect to this 2, with respect to this 2, and 2, 6. Yeah, 6 there, 6 same here. 6 alpha hydrogens, 2 plus 2 plus 2. In both the two cases, 6. Is it clear to each and everyone? Now, once the alpha hydrogens you got, now I will show the mechanism and the short trick. I will tell you the short trick along with mechanism. First example, example number 1. The examiner will give you 2 moles of acetaldehyde plus dilute NaOH. What should be the product? Now he will give question like this. Now first of all, let me tell you the short trick. The short trick, then I will tell you the whole mechanism. Short trick is that take 1 mole like this, CH3 CHO. Okay, this is the carbonyl compound. Now another compound, we are in need of 2 acidic alpha hydrogen atoms. Now this is the carbonyl group and that is the tail. Just consider one aldehyde's mouth, this is mouth, and another aldehyde's acidic tail, acidic alpha hydrogen, so this is tail. Just bring mouth and tail near to each other and remove water from it. Bring mouth and tail near and remove just water. Heat can be written over there or cannot be written over there. Now you see what product you are going to get, kids. CH3 CH and the new bond formed. New bond formed. 2 bonds newly formed. CH-CHO. This is known as aldol condensation product. Aldol condensation product. I hope that everyone got now how to cross check it, whether it is right or wrong, how to check it, secrets. I would like to say this carbonyl group and this is alpha carbon, this is beta carbon. It was alpha beta unsaturated, alpha beta unsaturated, right? It is alpha beta unsaturated. So this is your right product and this is known as croton aldehyde. Remember the name, croton aldehyde, croton aldehyde crisps, croton aldehydes. This is very famous name, croton aldehyde. Kids, you got it? That short trick, you got it? Now after this, I will tell you the mechanism. Once the trick you got, we can prepare any compound with this short trick. Okay, any compound, any compound. You liked it? First of all, do let me know in the chat section. You like this short trick? Kids, you got it or not? Got it. Nitishan, very good. You got it. Once you do these simple questions, then I will give you all the type of questions. Okay, Lahari is saying please repeat it. Okay, no problem, I will repeat it. Don't worry. Baba will tell you. Roshan got it. Now, Baba will tell you once again, but I will take another example so that everyone should get benefited. I will take another example. See another example. Suppose examiner has given you this question. Examiner has given you this question. Propion aldehyde. This question was given by examiner. Dilute NaOH and heat. Dilute NaOH and heat. Now what you will do? Some of you must be thinking that only 1 mole is given. Kids, these are number of molecules. 1 mole means contains 6.023 into 10 to the power 23 molecules. So what you have to do? Propionaldehyde is journal name. This is the journal name. Its IUPAC name is propanol. So write down propanol. How will you write propanol? CH3, CH2, CH double bond O. Now this is the mouth. I have told you this is the mouth. Mouth. Why I am saying mouth? Because oxygen delta negative and carbon delta positive polar bond. Now another molecule you have to take, but remember that you are supposed to take its acidic alpha hydrogen. So when you bring another molecule, this hydrogen is acidic alpha hydrogen. So how will you bring? Just remember that you have to bring like this. What number of students will do mistake? What mistake will be done by them? They will bring this hydrogen. Don't bring that hydrogen. That is beta. Just see. This is alpha and these two hydrogens are alpha. So just remove water from it. Just you are supposed to remove water from it. You got it? Don't do the mistake that you are going to bring that tail. That tail is not acidic. This alpha hydrogens, they are only acidic. So product will be CH3, CH2, CH double bond in between these two, carbon, CH3, CH double bond O. You can cross check it. Even you can cross check it. How to cross check it? See, just next to this functional group, this carbon is alpha and this is beta. So it is alpha beta unsaturation should be there. Alpha beta unsaturation should be there. I hope that you got it. I hope that you got it. If not, then let me give you another example. Let me give you another example. Just see another example of it. Just see another example. Suppose if I take 2 moles of acetone. If I take 2 moles of acetone and I put dilute barium hydroxide or NaOH, whatever you can take, and heat. Let's see what you are going to get. How to get it? Just see. CH3. This is the mouth of ketone. Delta negative, delta positive. So consider it to be mouth. Now you need what in front of this mouth? You need tail. These 3 and 3, 6 are acidic, but you need just 2. You need just 2. So bring like this. CH, H, CO, CH3. Whether this side or that side, both are acidic. So just what you're supposed to do, remove water. That's it. Remove water and your answer will be CH3, carbon, and this new bond formation. Examiner will ask carbon, carbon, new bond formation. Just check it out. CH, C double bond O, CH3. This is very, very famous compound. Macetyl oxide. Very, very important compound. Examiner will ask in IIT, NEET board examination, acetyl oxide. Very, very famous name, kids. Remember its name, acetyl oxide. Acetyl oxide. Very, very famous compound. Now check whether your product is right or wrong. How to check? This is functional group, just adjacent to functional group, that is alpha. This is also alpha. Alpha, beta, unsaturated. Now I think short trick you are able to understand. After this I will give you mechanism. But yes, if you got it short trick, then I want to see some green hearts in the chat section. I want to see some green hearts in the chat section if the short trick is okay. If you are able to understand the short trick, then I want to see green hearts in the chat section, kids. Everyone do let me know if you got it. Then I will go in detail with the detailed mechanism. Okay, now see, kids. Everyone is able to understand. And kids, wow, that's really Nitishan, Harish Rajni. I don't know Harish Rajni when the system is going to end. Baba mi Hema. Oh, Malya Varshini, you are Hema. Wow, that's really awesome. Now kids, let me tell you in detail. Let me tell you in detail the mechanism. Mechanism of aldol. Mechanism of aldol. Just see. So, suppose they have given 2 moles of acetaldehyde treated with dilute NaOH. And let's see what product we will get and how we will get. Just think by yourself. Mechanism means it's totally mathematical. No need to worry, no need to cram. This is one type of compound, that is another type of compound. This is having ionic bond. NaOH will break first. It will break to give you Na plus OH negative. Now, OH negative can behave as nucleophile as well as base. So, whenever somebody is having dual character, who will get the privilege, the preference? Base will always get more preference. So, base is always searching for acid because base likes acid. So, hey, you are too acidic. So, it will come over here. In the second step, it will approach to this acetaldehyde. Hey, I'm interested in your acidic edge. Now, that OH negative will say, hey, I love you. I love your acidic edge. So, this H plus will say, Ingeva, come over here, come over here. Even I love you. Just I want to go with you. I want to go with you. So this carbon will get negative charge and it will be like this. CH2 negative, CH double bond O. Now, till now you are able to understand. Now, what will happen in the third step? Now, the third step, another molecule of acetaldehyde will become carbocation. See how and why. This is delta negative, this is delta positive. Oxygen is more electronegative, this is less electronegative. So it will be like this, CH3, CH positive, O negative. Now see what can happen in between these two. If I say this is X, this is Y, what do you think? What can happen in between X and Y? Bro, you are having negative charge. Bro, I am having positive charge. Now they will form a bond, negative and positive. They will combine together to form a new bond. Ting, 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 ting. I like you. I love you. Oh, my love. Oh, my love. So, carbanion and carbocation, they will form a new bond. Let's see what is going to happen on the next page. Let's find out how the story will move ahead. Get still now if it is clear. Just to let me know in the chat section that you got it. Till now, namaskaram Satvik, but do let me know, kids, how the story is going to move. I will tell you, but till now, tell me it's clear each and everything. Is it clear, kids? Do let me know till now you got it or not. Har Har Mahadev. Okay, Lahari is so clear. I got it. Now let's see what is going to happen on the next page. I'm waiting. Ta ta ta, carbon bro, carbon. New bond formation, carbon. Just like Bharat and Ram, they were meeting. Just like Bharat Milap, just like Ram and Bharat, just like Ram and Lakshman, they are going to unite together. Carbon, bro, carbon, bro. Now let's see what's going to happen. Next page, carbon, bro. Carbon भैया तुम पास से आए, यूं मुस्कुराए. Carbon bro, तुम पास आए. So let's see what is going to happen. Carbon, bro. Ting. New bond formation, ting. New bond formation. Examiner will ask, new bond formation. Now let's see what is going to happen. CH3, CHO negative, new bond formation. CH2, CH double bond O. Till now, this compound in the starting, till now it has lost one acidic H and CO negative. It will take its H from water, because you see in the starting, this was NaOH. OH negative has taken one H plus water has been formed, and NaOH is waiting that I'm the catalyst. I will be like NaOH as the reaction is going to end. So let's see. This O negative will take H plus from water, and this will combine with Na plus to form NaOH once again. And this is aldol. You see, this is aldol. Now let me write down aldol clearly so that everyone can understand what do you mean by aldol. CH3, CHOH. Now new bond. This is the new bond. Now CH2, CHO. What I have told you, what is aldol? Remember that what I have told you. This is carbonyl group, functional group. This is alpha, this is beta. Beta hydroxyaldehyde. This is aldol. Aldol means two functional groups. Aldol is having two functional group, aldehyde and all for alcohol. Aldehyde, all for alcohol. Combination of two, aldol. Everyone got it? They have combined together. It has taken H from water, aldol. Till now it is clear. I think it's clear to each and everyone till now. Till now it is clear. Yes. Now how the dehydration will take place from aldol. Just see the dehydration. CH3, CHOH, CH2, CH double bond O, aldol. Now see, one thing is that in your examination directly you can remove water. This is alpha, this is beta. Remove OH from alpha and H from beta. This is the direct method, alpha beta. From here OH negative is going, so this will get plus charge. From there H plus is going, that will get negative, and negative positive, they will form a bond. You will get compound CH3. Double bond CH, CH double bond O. Croton aldehyde you got. Actual mechanism is a little bit lengthier but true. Little bit lengthier but true. See, this OH is poor leaving group. Actually, this OH is poor leaving group. Carbon is 2p, O is also 2p, so poor bond, so will not go easily. But this hydrogen is acidic, so easily leave. Now, if it is going to leave, you will get this compound. And here you will get negative charge because proton has gone. So you can say it has lost its proton. So this is the conjugate base. Conjugate base of that acid. Who is acid? This is acid because it has donated proton. So it is conjugate base. Once it is getting negative charge, it will give its electron to this carbon. Now the oxygen already having electrons, so there will be electronic repulsion. Electronic repulsion, and due to electronic repulsion, now this OH will go along with Na plus, and plus minus once again you will get compound same, but this is known as E1CB mechanism, but not in syllabus. E1CB, unimolecular conjugate base elimination. Unimolecular conjugate base elimination. In 2016 paper they have asked once. That was very tough paper, so I have told you each and everything how to get it. I think you got it. Just to let me know in the chat section, everyone is able to understand or not. Do let me know in the chat section. Everyone. Anion and cation. Okay, I will tell you anion and cation once again. What do you mean by anion and cation? The one who has got negative charge. The one who has got negative charge is anion. The one who has got negative charge is anion. This is anion. The one who is having negative charge. Negative charge one is what, kiddo? Kids? Negative charge one is anion. And positive charge one is cation. Just like your cathode and anode, you know, cation and anions. Now I think clear. It's clear. Now see, kids. Let me tell you something that which has been asked in the AIMS examination. Once they have given this question, 2 moles of this compound, and they have given dilute NaOH and heat. Dilute NaOH and heat. What product you will get? So just do it in your brain and then I will tell you the answer. See, directly you can perform this question's answer. How to do it? Just see. This is your carbonyl group. This is the mouth. You can say this is the mouth. Now, tail will come. You know, tail's acidic hydrogen will come. Tail's acidic hydrogen. Now see, this is the tail. Hey, hydrogens, where were you? I was in search of you. Oh, my dear, my dear, my dear. This is the tail, acidic tail. Remember that this is the acidic tail. I will remove your water. I will remove your water. Now water has eliminated out. So see what product you are going to get. Just see, This is the new bond formation. This is the new bond formation. Now check it out whether this product is right or wrong. How to check? How to check? This is carbonyl group alpha. Oh my god. This is not alpha beta unsaturated. Now what I will do? Mommy, this answer is wrong. Oh no. Once there is cycle, right hand side clockwise there is alpha, as well as on the left hand side is also alpha. Alpha beta. Oh my god. Alpha beta is not unsaturated. Now what I will do? Arey bacha, this is also beta. Yay! I'm the winner. I'm the winner. You got it, kids? Everyone got it? This is alpha beta. So correct. The mistakes, what mistakes you could do, I have told you those also. Hey, kids, everyone is able to understand or not. Do let me know that Baba is making all the efforts. You are able to understand or not, kids? Do let me know. Yeah, Lahari, thank you. Thank you. Everyone getting what mistake you can do, that also I am telling you. What to do, that also Baba is telling you. Baba is telling you each and everything. Now see, kids. Just see. Now, remember one thing, kids. Remember one thing. Remember one thing. Now let me tell you first of all one thing. Some people must be thinking from where to do questions. I will deal with all the questions in this session only. I will tell you each and everything. So no need to go anywhere, kids. No need to search for any question. I will let you know each and every question here only, kids, right? See. That's always they are giving dilute NaOH. Is it correct that always you will get dilute NaOH or something else also? You can get dilute NaOH. You can get dilute KOH. You can get dilute barium hydroxide. Even you can get dilute calcium hydroxide. Anything they can give you, all they are source of OH negative. If not given this, they can give you NaHCO3 aqueous. If you remember ionic equilibrium, that this will break to give Na positive, HCO3 negative, and once this is combining with water, it will form H2CO3. It will form H2CO3, and this will form NaOH. Now you can consider, you can understand this is strong base and that is weak acid. So ultimately you will get OH negative. So whether they are giving this, they are giving Na2CO3, all they mean same, or they are giving RONA, that means O negative Na plus. Once again, if you put it inside the water, RO negative, what will you get? You will get H delta positive, OH delta negative. So once again you will get OH negative. They are giving you ROK, then also same thing, just remember. And once they have given, see what they have given, BrO3 negative, Br negative plus water. Now you will consider that, oh my god, there is no OH negative. But remember that this reaction is reverse of which reaction? Br2 OH negative. If you have seen the redox titration, this side it is disproportionation reaction and that side it is proportionation reaction. Once again, they together combine to give you OH negative. So whatever is given, that means OH negative is there. They all are responsible for aldol condensation. These all reagents are responsible for what? Responsible for aldol. Remember that. Now let me see whether you will be able to do the question or not. So I'm going to deal with one question. This question is given in NCERT also. NCERT also, that if I take CH3, C double bond O, CH3, N molecules means many molecules. Whenever it is not mentioned, that means there are many molecules. So CH3, CHO, N molecules means once again many molecules. And dilute NaOH and heat. Dilute NaOH and heat. Kids, they will ask the question, how many types of aldol condensation products will you get? Question is, how many types of aldol condensation products will be obtained? That is the question. Now, do let me know in the chat section if you are able to understand. What's your answer? I want to see in the chat section what answer you will give, kids. Nevra is going for Puru, Sotmare is going for 4. So let's see what answer you people are going to get, whether your answer will be right or wrong. Let me check it out. Maximum people are going for 5. I can't understand how and why 5. So the correct answer will be, okay, let me tell you the story. Some are going for 3, some are going for 4. Now let me tell you story, one story. Let's have birthday party. Let's have birthday party. Let's see, if I say that I'm having 100 yellow balloons and gas is filled, in that gas is filled, okay? This is tail, this is mouth of yellow balloon. 100 balloon I am having green, 100 balloons I am having green. This is tail, this is mouth, and hydrogen gas is filled. Gas is filled in both. Gaseous balloon, they are filled with gas, and their collision is allowed. But remember that what we said, only tail and head, if they are reacting, we will count only 10. Tail and head will be allowed. Only this combination, tail and head. Tail can combine with head. Tail and tail will not be considered. Head and head will not be considered. Let me tell you, head to head will not be considered. Tail to tail will not be considered. Only tail and head will be considered. How many types of probability, that permutation and combination, how many types of combination are possible? That is answer. How many types of combinations are possible? Tell me, whatever the number of types of combinations are possible, that is going to be answer. Now let's see, can you celebrate birthday party? Can you celebrate birthday party? Then that is going to be the answer. Whatever the answer for this you are going to get, that is going to be the answer. Let me check it out. What answer you are going to give? Get fast. I want to see the correct answer in the chat section. Fast, kids. Quick. Harish Rajni, it will go up to 2. Harish Rajni, it will go up to 2. Please focus on the studies content. Try to give the answer. Don't think up to what time the session is going to end. That is very bad. So you have going for 1 or 2. See, kids. See, if I say the yellow one, yellow balloons head, yellow balloons tail, one combination. green balloon's head and green balloon's tail. This is possible. Green balloon's head but yellow balloon's tail is possible. Yellow balloon's head and green balloon's tail is possible. How many combinations are possible? Do let me know. How many combinations? Total 4 combinations. Are you able to understand? Total there are 4 combinations. See, this is self, this is self. These two are being self. These two are being self. Self head, self tail, self head, self tail, and these two are cross. So 2 cross and 2 self. Can you get it? 2 cross and 2 self. So the point arises, total answer is 4. Answer is being 4. That is 2 self aldol condensation and 2 cross aldol condensation. If you got it, kids. Now let's see 2 self and 2 cross, how to get it, how to understand. Self, let me write down self once. CH3, CH double bond O, its mouth, its tail, water will eliminate out, its mouth, its tail, water will eliminate out. Now 2 cross, its mouth, its tail, water will eliminate out, its mouth, but its tail, water will eliminate out. So see how the water is going to eliminate out this, this. So what product you are going to get? Here you will get crotonaldehyde CH3, CH double bond CH, CH double bond O crotonaldehyde. Once again, this product has come crotonaldehyde. Here water will eliminate out. What will you get? CH3, CH3, C double bond CH, CO, CH3. What is the name of this compound? Macetyl oxide. You know very well, I have told you a number of times. Macetyl oxide. Now here the cross, water will eliminate out. CH3, CH double bond CHCO, CH3. It is not having any special name, so no one can ask this special name. It's CH3, CH3, C double bond CH, CH double bond O. Now see kids, you got it? If it is clear to each and everyone, do let me know. If you're not able to understand, then also do let me know. I want to see in the chat section. Everyone, do let me know in the chat section. Fast kids, whether you got it or not. Everyone understood or not? I want to see in the chat section, kids. Nitishan, very good. Riya Desai, very good. So 4, not 5, it's 4. Very good, very good. That's so awesome, kids. You are getting it. That's really fantastic. This is really something very good, kids. Fantastic. Everyone, you are able to understand. That's really fantastic, something nice. Now let's see, kids. This also we have got. Now I will move towards intramolecular aldol condensation. Let me tell you, intramolecular. Are you ready for that? Intramolecular aldol condensation. Intramolecular aldol condensation. Intramolecular aldol condensation. Suppose the examiner has given this question. Now let's see how many alpha hydrogens are there in this compound. Just check it out. How many alpha hydrogens are there in this compound? Just check it out, kids, and do let me know. So you will see with respect to this 1, 2, 3, 1, 2, and with respect to that 1, 2, and 1, 2, 3, 5 and 5, 10 acidic alpha hydrogens are present, right kids? Right? Is it okay? Is it okay? Now see, anyone I can consider to be mouth. Suppose if I consider this is mouth. Now before I proceed towards product formation, let me tell you once again one thing. 6-membered ring is more stable than 5-membered and then 7-membered. This is the stability of ring. What? Stability of ring. Remember this point. This holds a hell lot of weightage. If you don't know this point, you won't be able to do anything. So remember this. Now see, if I remove oxygen and hydrogen from this place, 1, 2, 3, 4-membered, this will give 4-membered ring. This is going to give me 4-membered ring. But at the same time, if I remove this oxygen with those hydrogens, 1, 2, 3, 4, 5, 6, this will give 6-membered ring. So definitely 6-membered ring is being more stable. So what is going to happen? This oxygen will go along with these 2 acidic hydrogens. But now how to make the product? That is a little bit confusing part. But I will convert confusion part into sophisticated easiest thing. Nalla iriku Muruku idiyappam will convert into Romba Sulbam. Just see how to make Romba Sulbam. You can put here A, B, C, D. Just see A, anywhere you can write, either there A or here. A, B, C, D, E, F. How many membered ring? 1, 2, 3, 4, 5, 6. So I made 6-membered ring. Now, in this 6-membered ring, anywhere you can write A, but move according to that. Anywhere, wherever you want to write A. Suppose if I have written A, B, C, D, E, F. Now remember, at A and F, you form the bond in between A and F. New bond is formed between A and F. New bond is formed in between these two, A and F. So I am supposed to form a bond in between A and F. I have formed this bond in between A and F. Is it clear? In between A and F, new bond has been formed. Now see, at E, double bond O is there. At E, double bond O is there, right? Double bond O is there at E. Now, at A, methyl is there. At A, methyl is there. This is my product. I have got my product. Now check it out whether this is right or wrong. To check for right or wrong, what you're supposed to do? What are you being supposed to do? Carbonyl group, this is alpha, this is beta, this is alpha, beta. How many carbons initially we have taken? 1, 2, 3, 4, 5, 6, 7. So 6 and 1, 7. This is the product. You got it? How many of you are able to understand? If not, then do let me know in the chat section. I will explain once again. Wow, Gopinath, welcome. Welcome, Gopinath. Now do let me know, kids, how many of you got it? How many of you are able to understand? If yes, do let me know, kids. If not, then write down not able to understand. I will explain once again. No problem, kids. When Baba is here, no fear. No fear when Baba is over here, kids. Do let me know in the chat section that how many of you are able to understand. I want to see green signal in the chat section, kids. Now, if you got it, if you really got it, then I will give one question. I will give one question and I will have a doubt. Okay, Harish, Rajni, you are having doubt? No problem. Let's see. Let's see. If I give you this compound, just see. If I write like this, okay. 1, 2, 3, 4, 5, 6. If suppose examiner has given this question and he has written like this, dilute NaOH and heat. Now how to form the product? Just see this compound. This compound is having how many acidic alpha hydrogen atoms? 1, 2, 1, 2. Now any carbonyl group you can consider it to be mouth. Let us suppose this is mouth. And then this is going to be acidic tail. Acidic alpha hydrogen, that is going to be tail. What I am supposed to do? I will remove oxygen from mouth and 2 hydrogens from the tail. Then how to do that? How to do that? That I will remove these 2 hydrogens and this oxygen. So definitely the bond will form in between these 2 carbons. Directly the bond will form in between 2 carbons. Just see. CH, CH2, 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 CH, 2H have gone. So the new bond will get formed. New bond will get formed in between these 2 carbons. Am I right, kids? And this CHO will be still there. This CHO will be still there. Now, how many of you got it? How many of you got it? Now, check it out. How many membered ring is there? 1, 2, 3, 4, 5 membered ring. This is the product. Now, check it out. It is aldol condensation alpha, beta. This is aldol condensation product. Now, I hope you got it. Now I hope everyone got it. Now I hope that everyone got it, kids. Do let me know. Once again I am asking. If still not, then I will explain once again. If you remove 1 hydrogen, then you will get. Thank you, Jyoti. If you remove 1 hydrogen, then you will get aldol formation only. So for condensation, you have to remove 2 acidic alpha hydrogen atoms. You have to remove 2 acidic alpha hydrogen atoms. Yes, it is cyclopentene carbaldehyde. Fantastic. Now, let me give you another question which has been asked in AIMS, IIT JEE, everywhere. Just see. Just be ready for this compound. I am giving you all type of questions so that whenever they are coming in exam, you can directly do that. You can find out the answer. Dilute NaOH and heat. Now do let me know what answer you will get. How to do this? How to find out the answer? Just see, kids. How to find out the answer of this question? Do it, kids. Everyone. Now see, how many alpha acidic hydrogens are there in this compound? You see, these two, these two, these two, these two. 8 acidic alpha hydrogens are there. Now kids, if you consider this to be the mouth, then you are supposed to remove either these alpha hydrogen or these alpha hydrogen. If you consider this to be the mouth, they are the tails. Whatever you want to do, you are free to do. See. If I consider this to be the mouth, then I will remove these two alpha hydrogen atoms. Let's remove water. Just remove water. What you're supposed to do? Now see, in between this carbon and this carbon, new bond is getting formed. New bond is getting formed. Are you getting my point? Let's see. In between this carbon and that carbon, new bond is getting formed like this. This bond is getting formed. Am I right? And this ketone will remain over here only. No problem. Just check it out. This is 7-membered, that is 5-membered. That is okay. 7-membered ring. And that is being 5-membered. 5-membered. Is it fine, kids? Everyone got it? Everyone is able to understand this product? Just do let me know in the chat section if you got it, kids. I want to see in the chat section. No. 2 water molecules cannot remove. Otherwise, ring will be of less carbon atoms. Only 1 water can get removed. Kids, do let me know. You got it? Everyone understood? Everyone understood, kid? Now see, kids. If this much is clear, I've told you all the forms of aldol condensation, all the forms, whatever they can ask. Now see, kids, let me tell you one special case. Till now, I've told you all the aldol condensation in basic medium. All the aldol condensation I've told you in basic medium. First, let me tell you one rank deciding question. A rank deciding question. If you want to get top 100 rank, then you should know these things. What are these things? By chance, they are giving you that acetaldehyde on reaction with concentrated NaOH. Now, those who know that concentrated NaOH is used for Cannizzaro reaction, but this aldehyde is having 3 acidic alpha hydrogen atoms. So now what you will do? Cannizzaro or aldol? So remember that there will be repeated aldol condensation. Repeated aldol condensation. Remember this. Why? Because the NaOH is being concentrated and you will get brown resinous mass. Brown resinous mass. It's a polymer. It's a polymer. Now, kids, some of you might be thinking, sir, how? Please explain how we will get this polymer. See, kids, when 2 molecules of this have combined, we have got with 2 molecules, what we have got? We have got crotonaldehyde. That's fine. We have got crotonaldehyde. Now, one more molecule of this acetaldehyde will come. This is, you can say, not acidic because it is sp2 hybridized. So definitely the acidic alpha hydrogens will get removed, and in this way water will get eliminated out. Then what will you get, kids? What you will get? You will get product like this, CH3, CH double bond CH, and one more new bond formation, CH double bond CH, CHO. Now once again another molecule of acetaldehyde will come, CH double bond O. Now once again the water molecule will eliminate out. Just see, water molecule will eliminate out. The same thing you can see is getting repeated again and again. See this, and once again. So you will get CH3, CH, number of times to give CHO. So this is a polymer. So you have to put this one, this is the polymer. Now I'm going to tell you aldol condensation in acidic medium, if everyone is ready. Everyone is ready? How's the juice? Let me check in the chat section. Everyone is ready? Technoplate. Kids, everyone. No, Cannizzaro, for Cannizzaro there should be no alpha hydrogen. If there is alpha hydrogen, only aldol condensation will take place. I think that everyone is able to understand, kids. Till now each and everything is clear. I want to see in the chats. If you are able to understand each and everything, do let me know. Wow, Purushottam ready. That's really fantastic. Now, before moving to acidic medium, one top 10 rank question. Baba is going to give you one top 10 rank question. Top 10 rank question. Are you ready for top 10 rank question? Just see, kids. They have given like this. What should be the answer? What should be the answer? Okay, no heat is given, only OH negative. Just see what should be the answer. Just think about it. Just think about it. What answer you can get? What answer you can get, kids? Just think about it. Now see, kids. If you see, this is already aldol. This is already aldol. Focus on it. Already aldol. How? This is carbonyl group. This is alpha. This is beta. Beta hydroxy carbonyl. Beta hydroxy carbonyl. But what's the problem with this compound? The problem is that this is 3-membered ring, and 3-membered ring is not stable. Unstable aldol. Unstable aldol. Why it is being unstable? It is being unstable because of 3-membered ring. Now, kids, I've told you that aldol formation and aldol breaking is known as retroaldol. They are reversible. So aldol can get formed and aldol can be broken up. So breaking of this aldol will take place, but how to break that we don't know. Remember that to climb on the tree, it's a little bit tough, but to come down is even tougher than that. So it's very tough to break the aldol and to form once again the original compound. But I will tell you how to make it. I will make it easy. Okay, ready? In between alpha and beta, you break the bond. You need to break the bond in between alpha and beta, right? And to beta give oxygen, and this hydrogen will get shifted to alpha. Just you are required to this, break this bond. See, if you are going to break this bond, the bond is breaking up in between these two, bond is broken up, and you have given hydrogen to this, and this will become negative and this will become positive. Negative and positive, they will form a bond like this, and this has got hydrogen already. One hydrogen was here, one new hydrogen it has got, and it's like this. Now see, write it down properly. You can write it like this, or you can write it like this: CHO, CH2, CH2, and CO, CH3. Now you will say that OH negative is there. Now I will make my aldol. I will make my aldol. This is the mouth, because aldehyde more reactive. Aldehyde more reactive. Ketone less reactive. Now this is alpha hydrogen, that is also alpha hydrogen, that is also alpha hydrogen. So there are two with respect to this, 2 alpha hydrogen, with respect to that 2 and 3, 2 to 4 and 3, 7 alpha hydrogens are acidic. Now I will take it to the next page. But till now the breaking of aldol is okay. Always when you want to break the bond, alpha beta will break. From beta, H will go to alpha, and this will become aldehyde or ketone. This breaking is the most important thing. Just do let me know in the chat section. Breaking. Do let me know. Kids, do let me know. Kids, spammers are there, so always show me green hearts whether you are able to understand or not. I have told you in the starting only why aldehydes are more reactive. This thing, from this only I have started my session. Why aldehydes are more reactive. From here only I have started my class. Pooja Shri Devi, very good. Radha Vaneza, Nitya Shri, fantastic. Breaking of aldol is clear. I think I have missed something. No, 3, 4 and 5 carbons, right? 5 carbons are there. That's fantastic. Okay. Very good kids. Now tell me, I've told you that this compound, let me write down this compound on the next page, okay? Let me write down this compound on the next page so that we can move ahead. Now, 1, 2, 3, 4 and 5. I've told you 6-membered ring is being most stable. After 6, 5-membered, and then 7-membered. Now this compound is just having 5 carbons. 1, 2, 3, 4, 5. Vana, randa, monu, nale, anche. 1, 2, 3, 4, 5. Only 5 carbon. So if I consider this to be the mouth and this to be the acidic hydrogen, if I remove this hydrogen, then I will get compound like this: C double bond OH, CH2, CH2, C double bond O, and CH2 negative. This is carbonyl. And this will act as carbocation, C positive, O negative. And here the new bond formation will take place. See, new bond formation will take place like this. New bond formation will take place or not? Just to let me know, new bond formation. New bond formation will take place or not? Do let me know, kids. New bond formation will take place or not? Yes. So this bond will mature. So C, this will shift over there. O minus H, CH2, CH2, C double bond O, CH2, and new bond will form. And this will take one H from water, aldol. Now see, we have got aldol. See, is it aldol or not? Carbonyl group. This is alpha carbon, this is beta. So beta hydroxy carbonyl. This is your aldol. So from that aldol, that 3-membered aldol, 3-membered to 5-membered aldol, we have changed. So I hope that this is clear to each and everyone. I think this is clear to each and everyone. Now let me tell you aldol condensation in acidic medium. There are just 2 examples of aldol condensation in acidic medium. I hope that you are ready for that. Aldol condensation in acidic medium. In acidic medium. Just see. So they will give you acetone because ketones are not forming good aldol or ketol. So they are giving you dry HCl. If they are giving you dry HCl, kids, remember that you will get 4-ron polymer as the major product. 4-ron as major plus acetyl oxide. Now acetyl oxide to we know very well, but what is this 4-ron? 4-ron, major, and it's a polymer. Now see, kids, CH3, C double bond O, one acetone molecule. C double bond O, CH3, another acetone molecule. Now CHH, C double bond O, CHH. Now you can see that right now I am having 3 acetone molecules. How many? 3 acetone molecules. Now water will eliminate out. One water from here and another water molecule from here, and I will get the product like this. CH3, C double bond CH, C double bond O, CH double bond C, CH3 and CH3. This is known as 4-ron. Anything more than 2 will known as polymer, 4-ron. I hope this is clear to each and everyone. I hope this is clear to each and everyone, kids. Now, acetone, if acetone is going to react in acidic medium, and that acid is H2SO4. So, acetone plus concentrated H2SO4. Remember that. Concentrated H2SO4 is having more affinity for water. More affinity for water. Remember this point. More affinity for water. More affinity for water. So it will form macetylene. Remember that was macetyl oxide. Earlier it was macetyl oxide, but this is macetylene. What is macetylene? Try to understand, and how it will get formed, that also see. CH3, C double bond O, CH, one H, another H. Let me take another CH3, CH, C double bond O. The third one, let me take C double bond O, CH3, CH, H and H. 3 acetone molecules. Dry HCl also took 3 acetone molecules. It is also considering 3 acetone molecules, but see, it is going to remove more water molecules. There 2 water molecules got removed, but here 3 water molecules, they are going to get removed. And now see what are you going to get, kids. Just see, CH3, C double bond CH, CH double bond C. Now double bond C and CH3. I think CH3 over there. CH3, C and double bond C. You can see this compound, you can write like this, or simply you can write this compound like this. Macetylene, we will call it macetylene. I hope that everyone got. Now aldol condensation got completed. You will get all the questions in your examination from here only, kids. Now you must be thinking that aldol is completed, but let me give you one more question for rank deciding question. Then I will give you one break, kids. Okay, let me give you one more question, that is rank deciding, then I will give one break. Okay, kids? Okay, kids. Very good, kids, very good. Now see, this question is going to be the rank deciding. See, kids, rank deciding question. Rank deciding. Aldol formation. It is based on aldol formation. Just see to it. Suppose if they have given question like this, one equivalent of acetaldehyde and 3 equivalents of formaldehyde. Now what should be the product? They are asking about the product. Now see, kids, what you're supposed to do, it is having 3 acidic alpha hydrogens. Can you see? 3 acidic alpha hydrogen. Now you need a mechanism to do this question. The OH negative, here they will give you OH negative. The OH negative, that is the base, will come to this acidic hydrogen. Just see, kids, and will remove one acidic hydrogen. How it is going to remove one acidic hydrogen, let me tell you separately so that you can understand. Let's see the mechanism. This is acetaldehyde. The OH negative will come over here at this acidic alpha hydrogen, and it will take away this hydrogen without electrons. So this will get negative charge. Carbon ion will get formed. Now see, the another molecule, this is without alpha hydrogen, it is not having alpha hydrogen, without alpha hydrogen, so this will form carbocation like this, H, C, H, delta positive, delta negative, and now they will form a bond like this, they will form a bond like this. Are you able to understand? Carbon-carbon new bond formation. The carbanion, this one will act as carbanion who has lost its alpha hydrogen, will forming carbanion, and this will form carbocation. Carbocation, kids, carbocation. So carbanion, carbocation, carbon-carbon, bro, new bond formation. I think you are getting this point. Now see, CH2, CH double bond O, and this will take H from water, CH2OH. So in place of one acidic alpha hydrogen atom, we got CH2OH. Just the aldehyde molecule, in place of one acidic alpha hydrogen atom, it has removed that, and in place of that it has got CH2OH. So still two more alpha hydrogens are there, so it will react with two more formaldehyde, formaldehyde without alpha hydrogen, formaldehyde not having any alpha hydrogen atom. It will further react with two more alpha hydrogen atoms to do the same thing which it has done once, will repeat twice more aldol formation, twice more aldol formation. Kids, are you getting my point? Twice more aldol formation. So these two hydrogens will get removed, and in place of these two hydrogens, two more CH2OH. So the product will look like this, CH double bond O, one CH2OH, one more CH2OH, one more CH2OH. So this is the answer, kids. 3 times aldol formation, 3 times aldol formation. I hope everyone got it. Till now, each and everything I have told you about aldol formation. Now I will start with Cannizzaro reaction. In between aldol and Cannizzaro, I will tell you Claisen-Schmidt-Perkin, and then I will come to Cannizzaro reaction, right? But first I will tell you Claisen-Schmidt reaction, and then I will come to Perkin, and then I will let you know. But till that time, kids, do you want a break? You need a break or you don't need break? Just to let me know in the chat section. Do let me know in the chat section, kids. Everyone. Everyone, just to let me know. Fast, kids, fast. I want to see in the chat section, fast. Okay, then I will give afterwards. Right now there is no need of break. That's really fantastic. Loving it, loving this. This is very good, kids. Wow, fantastic. Baba is loving this. Wow, fantastic, kids. Really awesome, really awesome. Superb, superb, kids. Superb, 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 kids. Superb. Now, kids, I will give break after 30 minutes. Okay, then after 30 minutes I will give one break. Okay, after 30 minutes. But let me bring a glass of water for me. Let me bring a glass of water for me, kids. What is this Claisen-Schmidt reaction, kids? What is this Claisen-Schmidt reaction? See, whenever your one molecule is aromatic aldehyde, like benzaldehyde, and another molecule is aliphatic aldehyde or ketone, like acetaldehyde, having at least 2 acidic alpha hydrogen atoms. So what we call it, if it is not aromatic, we call it aliphatic aldehyde. So one aromatic aldehyde, benzene is aromatic, so aromatic aldehyde. One is aliphatic, which is not aromatic. They will combine together to eliminate out water. And the product which we will get, that is known as Claisen-Schmidt. It is nothing, only we can say it's cross-aldol condensation, nothing else. Cross-aldol condensation. This is known as cross-aldol condensation, application of cross-aldol condensation. So what do you get? This is going to be a product. And this is beautiful compound. Its name is cinemaldehyde. What do you call it? Cinemaldehyde. Everyone say cinema plus aldehyde, looking like cinema plus aldehyde. Cinemaldehyde. Everyone say cinemaldehyde. Alpha beta unsaturated. Alpha beta unsaturated cinemaldehyde. I hope that everyone got benzaldehyde, acetaldehyde, cinemaldehyde. Everyone got it. Now Perkin reaction. What is Perkin? I think you must have eaten chocolate. There is one chocolate known as Perk. Perk, when goes inside the mouth, Perkin. Now see, if I take benzaldehyde, remember that there is only one example of this, benzaldehyde plus acetic anhydride in presence of sodium acetate. Remember, these reactants, they hold a whole lot of weightage. What are the names? Benzaldehyde, once again let me tell you, benzaldehyde, acetic anhydride, sodium acetate. What I will get as the product? The product will be, kids, cinnamic acid. Everyone say that was cinemaldehyde. What here it is? Cinnamic acid. Kids. So this is Perkin reaction. I hope that everyone got it. Till now it's clear, kids. It's clear. This is the only one example. Now I am coming towards your favorite Cannizzaro reaction, 15 star, the most important reaction. But let me check it out in the chat. It's everyone got it? Till now it's clear. How it's going? How's the Josh? If fit and fine, I want to see fire symbol. If your Josh is high, Baba want to see fire symbol in the chat section, kids. And you have to make a promise that you have to consistent, because this chapter is very, very important, kids. This chapter holds a whole lot of weightage. Very, very important chapter, kids, for examinations. Any exam, board exam, IIT exam, NEET exam, whatever the exam, this chapter holds a whole lot of weightage. Really very, very important, kids. Really very, very important. So you have to remain consistent, right? Okay, Kenny Jaro. Jaro, Jaro. Jaro, Jaro, Kenny Jaro. Say everyone. Jaro, Jaro, Kenny Jaro. Now see. This reaction is shown only by aldehydes. RCHO, 2 molecules of RCHO. Rancho. Everyone say Rancho. Rancho, 3 Idiots movie, 3 Idiot movie, Rancho, but without alpha hydrogen. Rancho without alpha hydrogen atoms. On reaction with concentrated alkali. Concentrated alkali. How much concentrated? 50% to 99% concentrated, kids. Now, one molecule will undergo oxidation and another molecule will undergo reduction. Hey, the one who is undergoing oxidation will be known as Rexona. Everyone say it's like looking like name of soap. Rexona. Rancho got converted into Rexona. Rexona. And RCH2OH, primary alcohol. Primary alcohol, 1 degree alcohol. Now I will tell you the whole mechanism, but first get the feel that its oxidation state is 0. I will tell you on the next page. One is undergoing oxidation, one is undergoing reduction. So it is known as disproportionation, because carbon is undergoing oxidation and carbon is undergoing reduction. Disproportionation reaction, when same atom undergoes oxidation as well as reduction, such a redox reaction is known as disproportionation. Kids, tell me, what you got it? Such a redox reaction is known as what? Disproportionation. So if anyone is asking what do you mean by disproportionation, all those redox reactions where same atom is undergoing oxidation as well as reduction, they are known as disproportionation reaction. Now I will tell you each and everything in detail. I will tell you each and everything in detail, so you have to remain consistent. You have to wait and watch for each and everything and you have to answer it. Okay? Now, my dear friends, let me tell you, only 10% of the questions. Now, let me behave like, one character was there in 3 Idiot movie. Let me tell you one thing. Let me tell you one thing in detail. The Cannizzaro reaction, only 10% of the questions will require detailed mechanism, but rest of the 90% questions, they will be asked directly. They will be asked directly. So you have to remember, you have to cram it. Rancho, oh my God, where Rancho has given. Rancho, have Rexona and remove 1 degree alcohol. Say everyone, hey Rancho, just take a bath with concentrated alkali and put Rexona on your body and remove alcohol. Hey Rancho, have a bath with concentrated alkali. Just remove your dirt with Rexona and remove 1 degree alcohol, or remove 1 degree alcohol with Rexona. Is it okay? Is there in your brain? Have you fed it? Now see how to do the question. So if examiner is giving you a question like this, 2 moles of formaldehyde, now you know very well that they are not having alpha hydrogen reaction with concentrated alkali. What you will say? Hey Rancho, so R part is H. Hey Rancho, just put Rexona on your body and remove 1 degree alcohol from your body. You got the answer. Now if he is giving you benzaldehyde, second example, just see. 2 moles of benzaldehyde. Now what is the R part? Other than CHO, the part is given, that is R. So this is R. Hey Rancho. Hey Rancho, just have Rexona on your body. Just have Rexona on your body and remove 1 degree alcohol. Remove 1 degree alcohol. Now you're getting, it's working, Rancho 1. The trick is working or not, do let me know in the chat section. Trick is working or not, kids? Whether the trick is working or not, do let me know, kids. Thank you, Gayatri. Thank you. Thank you for appreciating words, kids. Do let me know the trick is working or not. Now, if I talk about cross-Cannizzaro reaction, if I talk, wow, thank you, kids. Now, if I talk about cross-Cannizzaro reaction, during cross-Cannizzaro reaction, remember that there will be different molecules. Cross-Cannizzaro. Different types of molecules. Suppose if I say one is formaldehyde without alpha hydrogen, another one is benzaldehyde without alpha hydrogen atom. Now who will undergo oxidation? Who will undergo oxidation? Remember that if you put fire on petrol and wooden rock, who will undergo oxidation? Definitely the one who is more reactive. Out of petrol and wooden log, who is more reactive? Petrol is more reactive, so petrol will be on fire. So out of formaldehyde and benzaldehyde, who is more reactive? Definitely this is aldehyde, simple aldehyde. This is aromatic aldehyde, and its carbon is doing resonance, so it is stabilized by resonance, so less reactive. Stabilized by resonance, so less reactive. So less reactive one will undergo reduction and more reactive one will undergo oxidation. More reactive. So this will undergo reduction, that will undergo, this will undergo oxidation, and that will undergo reduction. So the product will be HCON, the oxidized product. And RCH2OH, this is the reduced product. I hope till now everyone got. Now kids, I've told you each and everything, but before I move ahead towards the mechanism, I want to tell you something very great. See kids, what's that? If they are going to give you compound like this, one equivalent of CH3CHO, one equivalent only, and 4 equivalents of formaldehyde. Formaldehyde, 4 equivalent. Do you remember? In the aldol also I have given you such type of question. Do you remember, kids? Now see, there I have told you 3 times aldol formation will take place. How many times? 3 times aldol formation. So what you will get with 3 times aldol? 3 times aldol formation. We have done this. Am I right, kids? Are you able to remember? 3 times aldol formation it will give. Then what you will get? CHO. And on the carbon you got 3 CH2OH. Right, kids? CH2OH. 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 Now, neither this one is having alpha hydrogen. See, on this carbon there is no alpha hydrogen, nor the formaldehyde is having alpha hydrogen. None of them they are having alpha hydrogen. Without alpha hydrogen, without alpha hydrogen. Now what you will do? This one is also without alpha hydrogen. That one is also without alpha hydrogen, kids. Both of them they are without alpha hydrogen. Then in this case what you are supposed to do? Neither of them they are having alpha hydrogen. What are you supposed to do, kids? Cannizzaro reaction. Cannizzaro will come into the picture, and this is more reactive. More reactive will undergo oxidation. Less reactive will undergo reduction, so it will form CH2OH. Already 3 CH2OH are there. This will also convert into CH2OH. So total you got 4 CH2OH, 1 CH2OH, one more CH2OH, one more CH2OH, and one more CH2OH. Either you can write it like this or you can write it in a decent way. See why this is decent way, you will be able to understand. Same thing I am going to write like this. Now you will remember, oh my god, what is this? Kids, tell me, what is this? Do you remember? It's looking like swastik. Same thing. Both are same, but it's looking like swastik. See, it's looking like swastik or not? So 3 times aldol, 1 times Cannizzaro. Do let me know in the chat section. Everyone got it or not? Everyone got it or not, kids? Do let me know that you got it or not. Everyone. Do let me know, kids. If you're really loving it, show me some fire in the chat section. I want to see that how many of you are able to understand it. How many of you are really able to understand it? How many of you are enjoying it? How many of you are liking it, kids? Baba wanna see. Baba really wanna see, kids. Yes, kids. That's fantastic. That's fantastic. That's fantastic. Wow, that's fantastic. Now, let me tell you how this is reduction and oxidation. Let me tell you each and everything in detail. Let me tell you in detail. See, kids. Just see, kids. First of all, you have to find out what is the oxidation state of aldehyde. R C double bond O H. I have written that one molecule is undergoing oxidation to give you what? R C double bond O O N A. And another molecule is getting converted into what? 2 molecules we have taken, another molecule is getting converted into primary alcohol. Now let's see why we are saying that oxidation and reduction, they are taking place simultaneously. Just try to find out. This R group is putting plus I, so donating 1 electron, so plus 1 due to plus I. So plus I is looking like plus 1, plus I plus inductive effect. So this is donating electron, this is gaining electron. This hydrogen is donating electron, It's looking like H. So let me write down once again. It's donating electron. So once again it is gaining. Oxygen is more electronegative, gaining 2 electron because 2 bonds. So it is losing 2 electrons. So overall it is coming, kids, -1 and +2. Overall it is being 0. So in aldehyde or ketones, oxidation state is 0. Clear, kids? It's 0. Now see here, it is donating 1 electron, so +1. It is gaining 1 electron, -1. It is gaining 2 electrons, -2. Losing, so +2. From here 1 bond only, -1. So +1. +1 -1 cancelled out. So overall it is, this carbon is +2 oxidation state. So see, from here to there, from 0 to +2, oxidation is taking place. Carbon is undergoing oxidation, but see here, it's 0 only. From 0, now let's see, it is giving 1 electron, so +1, -1. It is donating 1 electron, so +1. -1. It is also donating 1 electron, +1, -1. It is gaining 1 electron, so -1, +1. +1 -1 cancelled out, so carbon is -2. So from 0 to -2, it is undergoing reduction. So you can see very clearly, my dear students, carbon is undergoing oxidation, carbon is undergoing reduction. Simultaneously, oxidation and reduction, carbon is undergoing, so it is disproportionation reaction. I hope everyone got it. Redox disproportionation. Everyone got it? It's clear? Now one point is clear. Now I will show you the mechanism for tougher questions. If they are going to ask tough questions, then for that we should know the mechanism, kids. We should have mechanism in our brain for tougher questions. But this is clear that it is showing disproportionation reaction. This point is clear. Is it clear to each and everyone, kids, till now? Do let me know, Pacha. Pyara pyara bachcha. All my dear kids, kiddo kids, do let me know that everyone is able to understand till now. Till now, is it clear to each and every one of you, kids? Now, first I want one promise from your side. I want one promise from your side, that how many of you will remain up to the last, Write down me. I will try to complete this session as soon as possible, but kids, I want one promise from your side, that how many of you will remain up to the last. I want to see that. I will give break whenever it is required. I will teach you each and everything in detail, whatever is required for your examination, because this time tough paper will come. Paper is expected to be tough. What I want to see in the chat section, that how many of you are making promise that you will remain up to the last. Let me check it out in the chat section. Let's see. Write down me. Write down, kids. Write down me. I will cover each and everything. I will tell you each and everything, but I want to see your promise, kids. Yes. Now, let me tell you the mechanism in detail, because they can ask anything. Just see the mechanism. Let's see the mechanism, kids. Suppose we have taken 2 moles of formaldehyde and we are reacting it with concentrated NaOH. Now let's see what is going to happen, how the product formation will take place. Just see. NaOH will break. NaOH will break like in aldol condensation. Now this time OH negative is not getting any acidic hydrogen. If it would have got acidic hydrogen, then it must have shown aldol condensation. But there is no acidic hydrogen on formaldehyde. Formaldehyde says that I don't have any alpha hydrogen. Now what you will do? No alpha hydrogen atom. I am without alpha hydrogen atom. Now OH negative will say I can behave as nucleophile. Right now I can't behave as base, but I will play my nucleophilic role. I will come and attack on your positive carbonyl carbon. Alright kids, this OH negative says that I will come and attack on this carbonyl carbon. Okay, inge ba, come. So the bond will form like this. Now kids, what will happen? What next? What next now? The another formaldehyde will come like this. There are two formaldehyde molecules. It will be like this. It was partial positive, partial negative. Now it will convert into complete positive and complete negative like this, kids. But now what next? The thing will get stopped over here. The thing is going to get stopped at this place. Remember that. The things, they are not working. Now kids, remember that we are not going to use concentrated alkali. You know that Le-Chatelier principle. Le-Chatelier principle says if you add more reactant, it will go more on the product side. Suppose if I am pushing some stone towards another direction, but I am not able to apply more force, do you think that stone is going to move, roll down? No. I have to apply more and more force. The Jallianwala Bagh Hatyakand massacre. General Dyer was firing from the behind and the people were running. They were just jumping inside that, what, the tick and the hold, because from behind too much force was applied. If somebody is applying too much force, the thing has to move in the forward direction only. So this has to move in the forward direction. Now what can happen? So see kids, ultimately this carbon will decide to release its hydride, and it will allow that this hydride should transfer on this carbonyl carbon. It's very sad. It's just like Eklavya has given its right hand thumb to Guru Dronacharya. There must be some force that Eklavya has donated its thumb, body part, to Guru Dronacharya. So it's like that donation of hydride, very tough. So it will take too much time. It is slowest step and rate determining step. Remember that this is going to be the slowest step. RDS. What do you mean by RDS? Rate determining step. Now I will show you this movie on the next page, but till now it's clear. Do let me know till now it's clear why this is slowest step and RDS. Because hydride transfer, examiner will ask in the paper, what happens in the rate determining step? Hydride transfer. Hydride transfer takes place in the rate determining step, hydride transfer. Now let me move on the next page with your permission, if everyone is ready. Now see, It's like this, H C H O negative OH. The another molecule is like this, H C positive O negative, and this hydride is going to move and it is going to this carbon, the rate determining step. Remember this. Now, how many molecules are involved in this process, RDS? If you apply chemical kinetics, one aldehyde, another aldehyde, and this has come from nucleophile. This has come from nucleophile. So, rate of reaction and the order of reaction. If the examiner is asking about the order of this reaction, then R is equal to K 2 aldehyde H CHO power 2 1 OH power 1. So 2 plus 1 3. So overall order of reaction is how much? Examiner will ask. Overall order of reaction is 3. Is this point clear to each and everyone, kids? Do let me know, is this point clear to each and everyone? Overall order, chemical kinetics, it will follow third order chemical kinetics. Do let me know in the chat section you are getting it. It will follow third order chemical kinetics, kids. Do let me know. It will follow third order chemical kinetics. Now, the one who is losing hydrogen along with electrons, this is undergoing oxidation, because loss of hydrogen and loss of hydride and electron, so it is undergoing oxidation. This molecule is undergoing what? Oxidation, because it is losing electron, undergoing oxidation. And this is gaining electron, that is losing electron, losing electron. This is gaining electrons, so it is undergoing reduction. So same carbon is undergoing oxidation and reduction. So after losing hydride, it will get plus charge, and this plus and this minus will form a bond. So this molecule will convert into HCOOH, and this after gaining hydride will convert into CH3. Just see, CH2H and one hydrogen from here, CH3 O negative. Now this is an acid, and acids are known for their proton donation. So it will give proton to this very fast step. This is going to be the fast step, and it will gain Na plus moving inside the mixture. So it will convert into HCOONA, and this will gain one proton from here. You will get CH3OH. In this way, the marriage got completed. So this marriage got happily completed. You got it or not? If yes, I want to see some fire in the chat section. Then I will tell you another by taking D and H. If you got it, I want to see some fire in the chat section. If you haven't got it, then no problem, you can write. Please explain Baba once again. So tough questions can be asked on this Cannizzaro reaction. So everyone just do let me know that you are able to understand or not. My pyara bachcha party, kiddo kids, Baba is waiting for your answer, your response, that you are able to understand or not, kids. Bachcha, everyone, bachcha, do let me know that you are getting it or not. Now let me give you rank deciding question. Now the rank deciding, they are going to give rank deciding. Just see, kids, whether you will be able to do it or not. Just think over it. By chance, if they have given this question, see, by chance if they have given this question, two molecules of HC double bond O D and concentrated NaOH. Now this question is given by them. Now it will become a tricky one. Tricky question, kids. Just think over it and then I will explain. Just think over it, kids. And then I will explain. See, kids. Now how to do it. In the first step, NaOH will break as usual. NaOH will break and that will give what? Na positive, OH negative. Now there is no acidic hydrogen, no acidic hydrogen. So OH negative will act as nucleophile and attack on this compound. See, H C double bond O, C delta positive, O delta negative, and this is D. That OH negative will come and attack on this carbonyl carbon. Now this will get converted to this form, HCO negative, this is D and this is OH. Now after this, another aldehyde molecule that is having partial positive, partial negative, it will form carbocation like this, HC positive, O negative and D. Now, what will happen? As I have told you, hydride transfer will take place or deuterium transfer. For this, you should remember one thing. This already you have studied number of times. That carbon to protium bond length is this much, but carbon to deuterium bond is this much. Which bond is stronger bond? Which bond is stronger bond? Definitely you should remember this is stronger, that is weaker. Why? Because 1 and 1, this is protium and this is deuterium. More the number of electrons, more stability of bond. Remember that. More the number of electrons, but electrons are same. They are isotopes. Isotopes have same electrons. So more the mass in case of isotopes. Remember that. In case of isotope, in case of isotopes, more the mass, more is the stability of bond. And even more is the donation of electron, that is through meson theory. So this is stable bond, or you can say more stable, and this is more weaker. Who will break then? Who will break then? Now you must have got it. This bond will break. So this will go to this carbon hydride shift. Now this will develop plus charge and it will convert into DCOOH. This will convert into DCOOH and this will get converted into CH2 1D O negative. Now it will transfer one H to this. This proton transfer will take place and this will convert into finally DCOONA. And this will convert into CH2DOH. CH2DOH. So this is the answer. Kids, you got it? Everyone got it? Just to let me know in the chat section that everyone understood the mechanism. Kids, do let me know that you got it or not. I want to see your answer in the chat section. That is it clear to each and everyone, my dear kids? Bacha, all kiddo kids, Baba wanna know that everyone is able to understand. Harry Bala, wow, great. Right now, don't ask any doubt. Once let me teach. After my teaching, if still doubts are there, then you are most welcome. Everyone, anyone want to ask doubts, you can, but after my class, once let me teach, because the doubt must be from whatever I am teaching only, from there only, kids. So right now, don't ask, just study. Now, Cannizzaro reaction. Now let me teach you, kids. Let me tell you. Now break needed. Okay, I will give at 10. Now I will give break at 10. Okay, that round figure. Okay, I will give break at 10. Now see, intramolecular Cannizzaro reaction. Just see, intramolecular Cannizzaro reaction. That if they are giving you compound like this, glyoxyl, suppose they have given you glyoxyl, what it is known as? It is known as glyoxyl, concentrated KOH. Now what you will do? One will undergo oxidation, another will undergo reduction. COOK, CH2OH. Now another molecule if they are going to give, just see to it. They have given compound like this. Now see, still there is no alpha hydrogen, but this is ketone, that is aldehyde. So ketone is stable, aldehyde being more reactive. So definitely aldehyde will undergo oxidation. It will oxidize and it will reduce. So what you will get? You will get compound like this. Now I hope this much is clear to all of you. Now one very tough question. One very tough question I am going to give you, kids. Remember that what will happen? What will happen if they are giving question like this? 2 moles of formaldehyde and the 99.9% concentrated NaOH is given. 99.9% concentrated NaOH. Then if they are asking what is the order of reaction, that question will become very tough. What's the order of reaction? So remember that they can ask order of reaction, one question. Second question, what type of anion it will get formed? Type of anion. Type of anion. Now kids, these are two very important questions. Now let's see how the reaction will move. First of all, the first step of the mechanism, NaOH will break, as we know that, Na positive, OH negative. This OH negative will attack on this formaldehyde as usual, very common thing. Delta positive, delta negative, OH will come and attack on this carbon. So awesome. HCH, O negative and OH. Now kids, this NaOH is that much highly concentrated that it can't wait. You know, when you are so hungry and mama is saying just change your uniform and then wash your face and blah blah blah, and then you can have food. Then you can have food, right? So see kids, the hydride transfer is going to take too much time. This hydride transfer is a rate determining step, slowest step. It will take too much time. So this OH negative is saying, I can't wait. I can't wait for so that much of time. I will snatch your proton. I will snatch your this proton. I will snatch your this proton. So kids, number of time we are snatching. Hey, just give me one samosa bite. Like this and that. So see, this compound will get converted into, this compound will convert it into HCHO negative, O negative, dianion, and this will transfer hydride to another molecule like this. Now, how many molecules are involved? Just tell me how many molecules are involved in the rate determining step. This hydride is moving to this. Now see, one O negative, this was the OH and this O negative. So 2 O negative, these 2 O negative have come from whom? See, this is involved, this one, and this was the OH. This was the OH, means this OH and this OH. 2 OH are involved and 2 aldehydes are involved. 2 aldehyde and 2 OH are involved. See, 2 OH are involved in the rate determining step and 2 aldehyde. 2 aldehyde, 2 OH. So R is equal to K aldehyde power 2 OH power 2. So overall order is 4. Overall order is 4. Overall order of reaction is being 4. Everyone got it. It's really rank deciding. Rank deciding. How many of you got it? If you really got it, I want to see some fire in the chat section. Hariwala, not understood. Now see, Hariwala, in the rate determining step, actually 2 aldehydes and 2 OH are involved. 2 aldehydes and 2 OH are involved. That's why its order is, overall order is, okay, recap. Okay, let me see. That number of kids here are asking, sir, recap, not able to understand. Okay, no problem. Let me explain once again. See, just see to it. Just see to it. Don't worry. See, this aldehyde, NaOH has broken into Na plus OH negative. OH negative has attacked on the aldehyde. OH negative is attacking. This is same as earlier we have seen. Now, this step is rate determining. This step is rate determining. So it is taking place very slowly, but their concentration is 99.99%, means number of OH negative ions are there. They can't wait. So what, they are always in need of proton. So they will come and snatch this proton only. So see, in the rate determining step, this is the slowest step and this is only the RDS. How many aldehydes are involved? One aldehyde, one more aldehyde. One OH we have got from NaOH only. See, this OH we have got from NaOH only, and this one more OH, already 3 was the order of reaction. This is extra OH. So 3 plus 1, we got 4 order of reaction. I hope that everyone got it. I hope that everyone is able to understand. No, Simran. No, Bhavesh. It's okay. It's okay. Everyone got it? Is it clear, kids? Is it clear to everyone? Now let me show you something that's really great. Just wait a second. Just wait for a second, kids. Now kids, see. If somebody is giving you HCH double bond O plus dilute NaOH. Now kids, what you will say? What is this? HCHO is having no alpha hydrogen. But why they have given dilute NaOH? This is going to be a question mark, kids, isn't it? Question mark, because for Cannizzaro reaction, we need concentrated NaOH. Then what you will say? It is not having no alpha hydrogen. So this is supposed to show Cannizzaro reaction, but you have given dilute NaOH. What is the meaning of this? My dear student, remember that. Neither aldol nor Cannizzaro. You will get one very, very important compound. See kids. Formose. What you will get? Formose. This reaction is not given in NCERT, but examiner will ask. Formose. What is formose? C6H12O6. Now you will say this is glucose? No. Fructose? No. Mannose? No. Galactose? No. It is formose. Brown colored resin. Brown colored resin polymer. Brown resin. A polymer, kids, a polymer. This is very, very special reaction. Very, very special reaction. Remember that. Mind blowing. Your mind has blown up or not? Kids, do let me know. It is really mind blowing. Tell me. Let me know in the chat section. It is really something very great. It's really something extraordinary. Walaikum salam, assalamu alaikum. Brown colored resin. Now let me show you something very, very awesome. See kids, let me tell you something really, very great. If somebody is giving you compound like this, chloral. If somebody is giving you chloral, Cl3 CHO. Can you see? Its name is chloral. Chloral. What do you think it's? It is having any alpha hydrogen? No alpha hydrogen atom. So suppose somebody has given you OH negative, what you will say? Will it show Cannizzaro reaction or aldol condensation? Remember that. Neither Cannizzaro nor aldol. It will form haloform test. Haloform test. 90% haloform test. 10% Cannizzaro. Now you will ask how and why, sir? That I will explain when I teach you haloform test. So it will form CHCl3 chloroform. This is also one very, very important reaction which holds a lot of weightage. Remember that. Now, after this, let me tell you one reaction, Tishanku reaction, and then I will give break. Then I will give dinner break. Okay, kids? First, let me teach you Tishanku. Have you ever heard the name of Tishanku? Tishanku. So, see. RCHO, 2 moles of RCHO. Now kids, in aldehyde aldol condensation, I have told you they should have alpha hydrogen. In Cannizzaro reaction, I have told you they shouldn't have alpha hydrogen. But here in Tishanku reaction, it says alpha hydrogen may be present or absent with or without alpha hydrogen atoms. Doesn't matter, alpha hydrogen are present or absent. This on reaction with the special reagent C2H5O whole thrice aluminium. What it is known as? Triethoxy aluminium. What do you call it? Triethoxy aluminium. Aluminium. It will undergo oxidation as well as reduction. One molecule will undergo oxidation, another molecule will undergo reduction, just like Cannizzaro reaction. You can say it's a type of Cannizzaro reaction. I will not say it's Cannizzaro. A type of Cannizzaro. Because in Cannizzaro also you got oxidized and reduced product. But just like one goat and lion cannot live together. Lion will eat goat, right? So acid will lose its OH and alcohol will lose its H. Remember that whenever esterification takes place, acid always loses its OH. It will get converted into ester. The final product will be ester. R C double bond O OCH2R. This is ester is the final product. Now kids, let me give the same reaction on next page and let me check it out whether you will be able to do it or not. One simple question and one rank deciding question. Let me give you first the simple question. 2 moles of CH3 CH double bond O C2H5 O whole thrice aluminium. Let me know what product you will get. Then I will give you tough question, right? So just find out the answer in your brain. So the answer will be, pause the video and just find it out. So one molecule will undergo oxidation, another molecule will undergo reduction, so now water will eliminate out. So final product will be your CH3 C double bond O CH2 CH3. This ester is the final product. What is the name? Ethyl acetate. Now one rank deciding question. Now let me give you one rank deciding question. This is rank deciding, kids. Find out the answer. What answer you will get? Just pause the video and try to find out what answer you will get, and then I will let you know, kids. Yeah, I will give break after this answer. After this answer, I will give break. Now, see, kids, how to do it. This will undergo oxidation, and this one will undergo oxidation, one will undergo reduction. Now you have to eliminate out water. Water will get eliminated out. Now product will be, final product will be C double bond O, O, CH2. This is your product, kids. Got it? Or if you rearrange it, write it properly, then you will see the product is looking like this. C double bond O, O. This is product. Everyone got it? So let's take a break, dinner break, and I think we all can do dinner in 40 minutes, right? 40 minutes is sufficient. Okay, kids, let's meet at 10:40. Okay, right now it is 10. Will it be okay? Do let me know in the chat section. Right now it's 10:40. Yeah, Simran, yes. In aldol it is acting as base, and in Cannizzaro it is acting as nucleophile. Okay, kids, do let me know in the chat section. Let's meet at 10:40. Do let me know. Show me green signal if you're agreed. Everyone. Okay. Okay, so let's meet at 10:40, and then we will deal with hello form test. Then we will deal with hello form test. But make a promise that everyone, you will come with same energy, even with more energy. Even with more energy you will come, kids. You will come even with more energy. Kids, do let me know. Make a promise, you will come with the same energy, kids. This is much more important. This is much more required, kids. With same energy we have to meet. With same energy. This is much more important, kids. Do let me know. Make a promise. Hey everyone, do let me know. Are you back? Everyone, let me see, kids. What's up? What's up, kids? What's up? You are more punctual than Baba, kids. Kids are more punctual than Baba, my dear students. Wow. Yeah, kids. Oh my God, kids, salute. Baba, salute you, kids. You are even more punctual than Baba, kids. Oh, great, great, kids, great, great. You are even more punctual. Everyone ready? If everyone ready, just show me fire in the chat section. Then we will start it. We are going to start. We are going to start with kids. With full on Josh. I want to see some fire along with green hearts, kids. Let's it go, let's it go, let's it go. Now, hello form test. This is very, very important reaction of the test. It holds a lot of weightage for your examination. Really gets mark my words. Just mark my words. Let's it go. See, hello form test. Hello form. Now in hello form, I would like to say it can be chloroform test, CHCl3. It can be bromoform test, CHBr3. Or it can be iodoform test. But how I will write iodoform, that I would like to say, that I would like to tell you, CHI3, where I have given more focus, where I have added more focus on iodoform. Why I'm interested in iodoform, kids? Its color is yellow. It's yellow papita, yellow PPT, and that makes it most important test. This awesome thing makes it most important. Although chloroform test, bromoform test, iodoform test, but most important is iodoform. Now your mind must be saying, sir, where fluoroform is missing? Where the fluoroform is missing? There is no fluoroform. Hey, where you have gone, my fluoroform? CHF3 is not there. It's missing. It's wing missing, kids. It's not there. It's not there. It's not there. Killed. Now, kids, what you are writing, sir? We are unable to understand. Kids, you are getting it. That our focus will be. Wow, kids, I can see your chats. Our focus must be maximum on iodoform test, iodoform test. This is the most important thing we are going to deal with, maximum for iodoform test, and during the mechanism we will come to know that why there is no fluoroform test. Right, kids? Right. Absolutely correct. Absolutely correct. Now let's see. First, I will tell you the reaction. Then I will let you know the mechanism, then each and everything. Okay. Now see, kids. This is a little bit lengthy. See to it. So the story starts from RCOCH3. Remember that, RCOCH3. This is the most important thing. This is known as methyl carbonyl. What do you call it? Methyl carbonyl. This must be present. Methyl carbonyl. Right now I'm moving like board exam. Like I'm acting like a school teacher. Then I will act like your IIT or NEET teacher, like so. Okay. First, let me tell you in the very standard form, methyl carbonyl, that is going to react with Cl2NaOH. It can be given like this, or that will combine together to form NaOCl. It can be given like this, NaOCl. It can be given like this, Br2 plus KOH. This will react together to form KOBr. Or it can be given like I2 plus NaOH. They will react together to form NaOI. NaOI. Now these three sets can be provided. These three sets can be provided. A set, B set, C set. Now they will react, and what are their names? They can even give you the names. This is known as potassium hypobromite. Remember that. Its name is potassium. Say everyone, potassium hypobromite. Bro is along with mite, looking like bro. Hey bro, hippo bro is with mite, and this is sodium hypoiodide, and this is sodium hypochlorite. Okay, like that. Now what you will get? Here you will get CHCl3 chloroform plus Rexona RCOONA and salt and water. That salt and water, NaCl plus water. In this case you will get CHBr3 plus Rexona or RCOOK, salt and water. And in this case you will get CHI3 yellow PPT plus Rexona plus salt and water. So in this case chloroform test, in this case bromoform test, in this case iodoform test. Just see. It's looking like a little bit haphazard, but nothing is like that. Everything is fit and fine, and I will explain one by one. I will tell you medico, I will tell you why fluoroform test will not take place. For that you have to wait for the mechanism. Medico, oh Sahana is there. Sahana, welcome. Medico, you have to wait for mechanism. So in this case we will say it is chloroform test. In this case we will say bromoform test, and this case we will say iodoform test. Chloroform, bromoform, iodoform. Now let me tell you something great. Suppose if I have taken COCH3 and this is the R part, you can see RCOCH3. But kids, let me tell you one thing in detail. This R can be what? This R can be what? Remember that this R can be hydrogen, or it can be alkyl, or it can be aryl. Remember that this R can be either hydrogen or alkyl or aryl. Are you getting my point, everyone? R can be either hydrogen or alkyl or aryl. It can be anything. What I'm telling you, remember that R can be hydrogen, alkyl or aryl. Now see, if I say that somebody has given you this compound HCOCH3, that is acetaldehyde. Now the R part is H, and that person has provided I2 plus NaOH. Now can you tell me what product you are going to form? Remember that H will convert into HCOONA, Rexona, Hasona, 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 HCOONA, and this will convert into yellow PPT CHI3 and then salt and water. That's the side product, salt and water, so you can leave it. Now suppose if somebody is giving you compound like CH3CO, CH3, now consider who is R. Just remember this part is R because COCH3, leave COCH3, other than this COCH3 the part is going to be R. So what product you will get? Kids, I2NaOH. So do let me know that R part is CH3, so CH3 COONA, CHI3 salt and water, they are same, salt and water will remain same. Now kids, do let me know if somebody is giving you C6H5COCH3. Now other than COCH3, what I am telling you, other than the COCH3, the rest part is what? R. So this is R. What you will get? What you will get, my dear students? You will get R, that is C6H5COONA, R plus CHI3, salt and water. Do let me know, kids, is it clear to all of you? This page is clear. Reactions you can frame out. Then I will move ahead. If it is clear, do let me know in the chat section if it is clear to each and everyone. Kids, do let me know if it is clear. Sahana, very good evening, very good evening. Everyone, just do let me know if till now it is clear to each and everyone. Everyone, just do let me know. Do let me know, kids. Fast, fast, fast. I want to see that everyone, you are able to frame out the product. Oh, very good, Hema. Fantastic, fantastic, fantastic. Now see, kids. See. Now let me tell you this in detail, mechanism. Baba is going to deal with mechanism. So be aware of it. Then only you can understand the mechanism. Suppose if I take compound, the story starts from here. R, C, H, O, H, CH3. Now this thing is missing in NCERT, missing part of NCERT. Baba is going to deal with missing part of NCERT. Now if you react this compound with I2 NaOH, remember that I2 is MOA. What do you mean by MOA? MOA means mild oxidizing agent. Now what will happen with that? One hydrogen will go from here, one hydrogen will go from here. Just see how it will go. One hydrogen will get lost from here and one hydrogen will go away from here. So two hydrogens will go away. Now this was the alcohol. The story starts from alcohol. I will tell you what type of alcohol they can be. They can be primary or secondary alcohols. Now they will get converted into this type of compound, R, CO, CH3. Now what is this? If this is hydrogen, then aldehyde I would like to say. And if this is carbon, then I would like to say it is ketone. Now which aldehyde, which ketone, I will tell you later on, right, in detail. Now kids, the point starts from here. The main story is going to get started from here, that we have taken I2 and we have got NaOH in this way only. Now we are having three types of reactants. Totally we are having three types of reactants. Who will start the story? You know, whenever there is fight, somebody will be there who is going to start the fight. Someone who is going to initiate. Then this OH negative is interested in acidic hydrogen. He will come and will say, hey Minchungu, I want one hydrogen. Just give me one hydrogen. I need one proton. So just give me this proton. I'm loving this. Oh, So he has taken that proton. Now Na plus will take I negative, NaI will get formed. Now this I plus will come and take entry into the life of carbon. Hey carbon, I don't like you, but then also I'll be yours, because there is no one to whom I should love. You are the only one whom I can love. Okay, carbon is saying, let's form a bond. Now kids, what is going to happen? See, in the story there is going to be one twist. In this way, carbon has lost one hydrogen and one iodine got the entry into the life of carbon. In this way, overall, carbon has lost one hydrogen and got the entry of one iodine. So this will be known as aldehyde or ketone. Now iodine will start calling his brother or sisters, hey, Ingeva, let's attack on carbon, let's attack on carbon. So they will start attacking on carbon. In this way, one more hydrogen will go, one more iodine will come into the life of carbon. Now two iodo are there, diiodo, aldehyde or ketone. Now one more I2 will come into the life of this, one more I2, NaOH. Now iodine is saying, hey carbon, now we are three. Now we are three, you are one. So iodine is three, triiodo. Aldehyde or ketone. Now once again OH negative will come. Now OH negative will say, hey, you're all the acidic hydrogens. You were having three acidic alpha hydrogen atoms in the starting. Now you are having no acidic alpha hydrogen atom. So I will act as nucleophile. Now I will not act as base. Till now I was behaving as base, but now you're not having acidic hydrogen. So I will attack on your carbonyl carbon by behaving as nucleophile, and you will get turned into this compound. Now what you will do? Now this carbon, till now you have seen in the movie, carbon-carbon new bond formation, carbon-carbon new bond formation, but this is the first time that carbon-carbon bond is going to break. Carbon-carbon bond is going to break. This is the first time this carbon-carbon bond will break. Breaking of bond. मैंने संज्ञा जी से आज ब्रेकअप कर लिया, सुबह सवेरे उठकर ये सब कर लिया. Breakup song. Now there will be breakup song. Kids, there will be breakup song. Now there will be breakup song. Now my dear student, till now it's clear. Just to let me know, till now is it okay? Till now everyone is able to understand, kids? Do let me know. I want to see in the chat section. Till now is it okay? Carbon-carbon bond is going to break. Breaking of bond will take place. Pucho Q. Breakup will be there. Now let me show you the breakup on the next page. On another page, let me show you this breakup. Ting 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 breakup song. RCOH O negative. Bro, I'm going away from your life. Bro, I'm going away from your life. Now carbon is asking, will you take electron? Yeah, I will take your electron because you will develop plus and minus. You can form a bond with this. R, C double bond O, OH, and this carbon will eliminate out. Carbon negative, iodine, 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 right? Now this acid will transfer one electron to this, sorry, one proton to this. This proton is acidic. So acid will transfer this proton to this. It is acid, that is base. Now my dear friends, first of all, before getting this proton, why this carbon has broken up? That means carbon has broken the bond, breaking of bond. Why this breaking of bond has taken place? Why the breaking of bond has taken place? See, this carbon is having extra electron in the 2p, and iodine, if you remember, fluorine, chlorine, bromine, iodine. Fluorine belongs to second period, third period, fourth period, fifth period. Everyone is having vacant d orbital. It is having 3d vacant, it is having 4d vacant, it is having 5d vacant. These are the vacant. But my dear friends, can you say that 2d is vacant? No, 2d is not vacant. Now why I am talking about vacant orbitals? Because this electron will go and will do back bonding in 5d, because electron wants to delocalized. If electron is getting more space, then electron will feel more happy. Delocalization of pi electron will take place. It will go to its 5d, it will go to its 5d, it will go to its 5d. So it will do back bonding, 2p, 5d, back bonding, and this will become stable. But in case of fluorine, no back bonding is possible. No back bonding would have been possible. That's why there is no fluoroform test. That's why there is no fluoroform test. Fluoroform test will not be there. No fluoroform test will be there, kids. You got it? Now the reaction will take place. R COONA plus CHI3. Now I hope that everyone must have got the reason why fluoroform test is not possible. Why fluoroform test is not possible, kids? You got the reason? Are you able to understand, Medico? Medico, you got it? Yeah, yes. That carbon is in very bad position. Now everyone got why there is no fluoroform test? Because there is no back bonding possible, kids. Do let me know you got it or not. Now, kids, let me write down one note and then I will tell you something very important. One note. Let me tell you one note, then I will tell you some very important points. Note is that during haloform test, or reaction, double bond does not affect it. Double bond remains unaffected. Double bond remains unaffected. Double bond remains unaffected. For example, this example is given in NCERT only. If I give you this compound CH3, CH, double bond CH, CH2, CO, CH3, I2NaOH. Now what I have told you, kids, what I have told you, just remove this parts. Other than this, the rest of whole part is R. This one is R. This whole part is R. This thing I have told you or not? Do let me know. The whole of the rest part will act as R. This is R. So double bond will remain unaffected. The product will be CH3, CH, double bond CH, CH2, COONA, plus yellow PPT of CHI3, CHI3, salt and water, salt and water. So this point is clear. Double bond remains unaffected. This will not be touched. Now, compounds which will show positive haloform test, that is very, very important. Compounds which will show positive haloform test. See, kids. Compounds which will show positive haloform test. Now it's your turn. You have to find it out. You have to apply your brain. Everyone, are you ready? You have to use your brain. Compounds which will show positive haloform test. Now everyone, just apply your brain. It's your time. Kids, it's your time. Are you ready for this? See, if I ask you, tell me the name of aldehyde. How many types of aldehydes will show positive haloform test? What's your answer? The answer will be only one aldehyde, because we need COCH3. This is the necessary condition. And place of R I can keep H. In the whole world, this is the only aldehyde which will show positive haloform test. Remember that this is the only aldehyde. If I ask ketone, so no, aldehyde, ketone, yeah. If I ask ketone, then all 2-on of this world, all 2-on. For example, if I say all 2-on means CH3, COCH3, it will show CH3, CH2, COCH3, it will show CH3, CH2, COCH3, it will show CH3, CH2, CH2, COCH3, it will show. But if I say that this will show CH3, CH2, C double bond O, CH2, CH3, then the answer is no. This will not show the haloform test. Now, kids will ask, Pucho kyun? Why? Why this will not show? Kids, it will not show because this is not 2-on. Just adjacent to CO, there must be COCH3. This is required, but you see, COCH3 is not there, CH2 is there. That's why the question will be, how will you distinguish in between pentane 3-on and pentane 2-on? What should be answer? How will you distinguish pentane 2-on? This is the question. Pentane 2-on and pentane 3-on. How will you distinguish? This will give negative iodoform test. Negative iodoform test. And this will give Positive iodoform test. All these will give positive iodoform test. Are you able to understand the language? First of all, do let me know, kids. Everyone, are you able to understand? Are you able to understand the language of the question, kids? Everyone, just to let me know. You are able to understand what I am telling you. Kids, do let me know. You are getting it or not. Are you able to understand the language? Very good evening, smart boy. Do let me know that everyone is able to understand my language or not. My dear students, I want to see in the chat section whether you are able to understand or not. Hey everyone, Bow is just waiting. Hit the like button, smash the like button. Keep still now if you're not done that. I want to see likes, at least 200 kids. In the starting also, I haven't asked for the likes. Smash the like. Hit the like button, smash the like button, kids, smash it. I want to see at least 200 likes. It's 188, 12 more likes will make it 200 kids. Fast. Only 9 more, only 9 more kids. Only 9 more likes. It will make it 200. Only 9 more likes. 1 aranda more nunale anchiare ere ette umpad pad. Ette only, 8 only. Okay. Let's move here. Now if I talk about alcohol, do you know any alcohol which will show positive iodoform test? In your knowledge, any alcohol? Do you remember any alcohol? So I've told you that it should be RCHOHCH3. It should be like this. So primary alcohol, if I ask about primary alcohol, to make it primary alcohol, what you're supposed to do? To make it primary alcohol, here should be hydrogen. If you keep in place of R hydrogen, then it will look like this, and you know this alcohol very well. The whole world is drinking this alcohol. Not good for health, but they are drinking. CH2OH, ethyl alcohol. This is the only alcohol, 1 degree alcohol, which gives haloform test. Now if I talk about 2 degree alcohol, so remember that in 2 degree alcohol, I would like to say all those secondary alcohols which are 2-alls, which are 2-all. What do you mean by 2-all? Just see. If I say CH3, CHOH, CH3. So if you count 1, 2, 2-all, CH3, CH2, CHOH, CH3. Once again, it is 2-all. CH3, CH2, CHOH, CH2, CH3. It is secondary alcohol, but it's not 2-all, so it will not give haloform test. It will not show haloform test. It is secondary alcohol, but it's not 2-all. That's why. Can you get it? Not 2-all means will not show. Now other compounds which will show positive haloform test. Just see, kids. If I write down CH2 Cl, C double bond O, and here can be hydrogen, CO, CH, 2Cl or 2X, H, CO, C, Cl3. It can be like this. These are aldehydes, halogenated, monohalogenated ditri. They can be ketones like CH3, CO, CH2X, or chlorine, whatever I can write, you can write CO, CHX. Now you must be thinking X can't be fluorine. Remember that. It can't be fluorine. X can be chlorine, bromine, or it can be iodine. That's okay. CH3, CO, CX, X. Now in your brain it will come that Sir, you taught us during Cannizzaro reaction that chloral shows haloform test. Now, what's the reason for that? I will let you know, but let me complete this first, okay? Let me complete this first. Just see. Some very special compounds which shows haloform test. Some very special compounds which shows haloform test. Very special compounds. See kids, what are these very special compounds? Let's see. Lactic acid. Do you know the formula of lactic acid, kids? Lactic acid. CH3 CHOH COOH. This is lactic acid. Pyruvic acid, kids. Do you know pyruvic acid? Pyruvic acid. Pyruvic acid is CH3 C double bond O COOH. Pyruvaldehyde. Pyruvaldehyde. What's that? CH3 C double bond O CHO. Now my dear students, once I am going to tell you these compounds, now there the chances of your negative marks will increase. Why they will get increased? Let me tell you, kids. These are all these compounds which will show positive haloform test. But remember that at the same time, I will tell you the compounds which do not show haloform test. It's very important to understand. No one is going to tell you the compounds which will not show haloform test, but you will definitely you will get trapped in the examination. That's why it becomes very necessary to let you know. Compounds, mark my words, very important point. Compounds which will not show haloform test. Very important, kids. Very important. Why I'm telling you if they are not going to show haloform test, then why I'm telling you for what I'm telling you? See kids. CH3 C double bond OOH. Acetic acid will not show. Lactic acid was showing, but acetic acid will not show. Why, sir? Why? I will tell you the reason. CH3 COX will not show. CH3 C double bond OOR will not show. CH3 C double bond O C double bond O CH3 will not show. These four types of compounds will not show haloform test because their hydrogens are not acidic. Hydrogens are not acidic. Now the question arises, why their hydrogens are not acidic? Not acidic. And why we will mark wrong? See kids, COCH3, all they are having carbonyl methyl, and that's why the chances of getting trapped increases. Kids, first see to it. The chances of getting trapped will increase or not, because all they are having what? All they are having carbonyl methyl. All they are having carbonyl methyl, so chances of getting trapped will increase in the examination. Am I right or wrong, kids? Do let me know first of all. Everyone just do let me know first of all that the chances of getting trapped will increase or not. Yes, Sahana is right. Rest of the kids, you are busy in talking. That's very bad. Now see kids. why their hydrogens are not acidic. First of all, let me tell you why their hydrogens are not acidic. See, if it is going to donate its H, it will become like this. Now it will ask to carbonyl carbon, just do resonance with me, but carbonyl carbon will say, hey, I'm busy with someone else, my pi bond is doing resonance with this oxygen, so I'm not free. My resonance is already going with that, so I can't help you. This oxygen said, hey, I can't help you. So he will say, hey hydrogen, please don't go away, I'm yours, I will never let you go, never let you go, I will never let you go. So this will never lose, because otherwise will become very, very unstable. So he will start crying that hydrogen, I don't want to lose you. So all these hydrogens, they are not acidic. But remember that this ester, this is carboxylic acid, this is acid halide, this is ester, this is anhydride. Esters, very special type of esters. Remember that all ethyl esters, if I talk about all ethyl esters, it's a very, very important note. All ethyl esters will show haloform test, will give haloform test. What is this, sir? This you said they will not give haloform test. Here was ester. Here you said they will not give. Now at the same time you are saying that all ethyl esters will show haloform test. What is this, sir? What is the meaning? Let me tell you, kids. If there is ethyl ester, let me show you, kids. R C double bond O O C2H5. This on hydrolysis, this on hydrolysis will give RCOOH plus ethyl alcohol, and ethyl alcohol is the only alcohol in this world which is used for drinking purpose. But here I mean this is the only alcohol which gives positive haloform test. So it will react with this and will show positive haloform test. So actually it's not the ester who has given this haloform test. It is actually the alcohol who's responsible. This is actually the alcohol who is responsible for giving this positive haloform test. So this point becomes very, very important. Do let me know in the chat section that if everyone is getting it, everyone got it. Kids, do let me know. If everyone is able to understand, do let me know, kids. Fast. Here O'Brien, welcome. Newton, Sunny. Oh my, great, goodbye, dear students. Wow, I'm happy to see you. Undergoing resonance already. Oh my God. Now, I've told you, got it. Heisenberg. Oh my God, Heisenberg, you are there. Heisenberg, are you the same Heisenberg whom I know? Are you the same Heisenberg? Praveen is there, here O'Brien. That's really fantastic, kids. That's really fantastic. Now, kids, so haloform test is clear to each and everyone. Now, let's move here. Let me tell you something more. Tolerance test, the most important thing. Before I move towards tolerance test, this comes under the category of oxidation of aldehyde and ketones with mild oxidizing agent. Haloform test is also under the category of oxidation only. So actually I would like to say all these things comes under the category of what? They all comes under the category of oxidation. They all comes under the category of oxidation. If I talk about oxidation of aldehyde and ketones, so how many things are coming under that category? The haloform test comes, and tolerance test, Falling's test, Benedict's test, and Skip's test. And all these are Warner and Monu, Nale and Chip. 5. All 5 are mild oxidizing agents, MOA. They all are MOA. MOA means mild oxidizing agents. Mild oxidizing agents. So now we are going to deal with tolerance test. Are you ready, kids? In NCERT only 2-3 lines are given, kids, but I will tell you each and everything whatever is required for your examination, whatever is needed for your examination, I will tell you in detail, kids, because number of questions will be asked from that. Are you ready? If yes, I want to see fire in the chat section. I want to see fire in the chat section. If everyone is ready, kids, if everyone is ready, I want to see fire in the chat section, kids. Fast, kids. Okay. So, let me start. See. Tolerance test. There is one, suppose beaker. When you go to the lab, very bad beaker I have drawn. Now let me draw it. So let me take, this is the boiling tube. Let's say, for example, this is the boiling tube. In the boiling tube, let me take water, neer, thani, thanir, vellam, pani, jal, whatever you want to say. Now in this, let me put the test tube. This is the test tube, see kids, test tube. And in the test tube, let me put organic compound. Let me add organic compound which has to be detected. I'm in the laboratory, right? Chemistry lab. I'm in the chemistry lab. This is the organic compound, kids. Now there is the organic compound. Now let me add tolerance reagent to this. I'm going to add tolerance reagent to this. Tolerance reagent I have added. And let me add some fire, heat. I have given heat. Let's see. If there is aldehyde, then you will get gray colored silver mirror, and the test tube will become like gray, kids. It will look exactly like silver. This test tube will turn out to be silvery test tube. You will not leave in your school. You will take it back to your home. It will look exactly like silver. It's silver. Now what has happened over there, that we have to understand. Remember that what is tolerance reagent actually. Tolerance reagent is freshly prepared. Freshly prepared. Ammoniacal silver nitrate solution. Ammoniacal silver nitrate solution. Silver nitrate solution. What's that? That is AgNO3 plus ammonium hydroxide. What's that? This on heating will convert into what? That I will write down in the next page. But this experiment, I hope it's very much clear to each and everyone, right? Now when you are going to heat it, what you will get in turn, that I'm going to tell you. But before that, before I move ahead, kids, do let me know till now this is okay, this is clear to each and everyone. Is this much clear to each and everyone? Kids, do let me know. I want to see that till now it's clear, so that Baba is going to move to the next page. Till now, is it clear to each and everyone, kids? Yes, yes, fast, do let me know. Be fast. Now, AgNO3, very good, very good, very good. AgNO3 plus ammonium hydroxide. AgNO3 plus ammonium hydroxide. What you will get? Here is your AgNO3 plus ammonium hydroxide. AgNO3 plus ammonium hydroxide. This on heating will give you AgNH3 whole twice OH, or you can see this to be AgNH3 whole twice positive diamine argentate 1, or you can get it like this, Ag2O. Remember that in all these things, one thing is very common. What's that? The thing which is common to all these is Ag plus argentus. Argentus. This is the most important thing, argentus, and it wants one electron. It is in need of one electron so that it can undergo reduction. It can undergo reduction to become shining silver mirror. It wants to become shining silver mirror, bright shining silver mirror. Now kids, this process is reduction. So you can say it is searching for electron, one electron, just one electron. It is searching, it is asking, hey, who is going to give me one electron? Who is going to give me one electron? But it cannot snatch electron from ketones. It can snatch electron only from aldehydes because it is mild oxidizing agent. So what it will do? It will react with aldehydes, whether aliphatic or aromatic, doesn't matter. Aliphatic as well as aromatic. It will react with that twice of AgNH3 whole twice positive in basic medium. Basic medium. This is basic medium. and it will oxidize RCHO to RCOOH, and itself will become 2 moles of AgPPT, 3 moles of ammonia plus water. This is the reaction. But it can attack, this is Tollens reagent, it can attack only on aldehydes, not on ketones. So ketones will remain unaffected. Remember that ketones will remain safe. Ketones will not be affected. Ketones plus Tollens reagent, no effect. No effect. No effect, kids. Okay. Now, kids, now you must start thinking, sir, fructose is a ketone that gives positive tolerance test. Then how is it possible? Kids, I will tell you each and everything in detail. First of all, do let me know you got it. So ketones will not be affected. So it's a very, very important thing. It's a very, very important distinguishing test in between aldehyde and ketones. In between what? In between what? In between aldehyde and ketones. Aldehyde and ketones. Aldehyde and ketones. It's a very, very important distinguishing test in between aldehyde and ketone. If somebody is asking how will you distinguish in between acetaldehyde and acetone, very simple. Acetaldehyde will give positive tolerance test, whereas acetone will give negative tolerance test. Now, compounds which shows positive tolerance test, this holds a hell lot of weightage. Very, very important thing, kids. Compounds which shows positive tolerance test. Are you ready to understand? Compounds which shows positive tolerance test. Are you ready, kids? Compounds which shows positive tolerance test. First thing is that we know very well all aldehydes, this we know very well, all aldehydes second is N-phenyl hydroxylamine. Nowhere you will get this much of quality content, so remember that, note it down, make a note of this. N-phenyl hydroxylamine will look like this. Third is hemiacetal. You know that, kids, hemiacetal in basic medium will convert into acetaldehyde only, RCHOHOR. In basic medium they will convert into aldehydes only, kids. Fourth is formic acid. Now, kids, why formic acid will give this test? Sir, you said aldehydes will give this test. Why formic acid? Kids, see, H C double bond O OH. This is the only acid in this world which is having CHO group. This is the only acid in this world with CHO group? Have you ever thought that an acid is having CHO group, aldehyde group? Do let me know in the comment. An acid having aldehyde group. Have you ever thought like this? Now, fifth one. Fifth one is R C double bond O CH2OH alpha hydroxy ketone. All ketones. Which type of ketones? All alpha hydroxy ketones. Will give positive tolerance test. Sixth is all monosaccharides are reducing sugars. Why? The sugars which are reducing agent, because aldehyde, see this reaction is redox reaction only. This reaction is redox reaction only. Why it is redox? This is undergoing oxidation. The one who is undergoing oxidation is known as a reducing agent. This is undergoing reduction. The one who is undergoing reduction is known as oxidizing agent, more mild oxidizing agent. So it is a redox reaction only, kids. So what I am telling you, all monosaccharides, you know, saccharides, all monosaccharides are reducing sugars. Because they give positive tolerance test. Examples of reducing sugars, you know very well, glucose, fructose. Now you will say, sir, fructose is a ketone, ketohexose, then why, sir? I will let you know the reason for this. Mannose, galactose, all they will give, kids, all they will give. All disaccharides, are also reducing sugars. Except, remember that, except sucrose and trehalose they are not reducing sugars. Now, eighth, all alkynes with terminal triple bond will give positive haloform test, not haloform, tolerance test. Now kids, it's a little bit different. Here silver mirror will not obtained. You will get white PPT. Let me show you. They are having acidic hydrogen because this is sp hybridized, so this is acidic hydrogen. So if you react it with tolerance reagent AgNO3 plus ammonium hydroxide, my dear students, you will not get silver mirror. Then what you will get? you will get white PPT of AG, C triple bond C, AG. But color means a lot, something great thing. White PPT of silver acetylide. Its name is silver acetylide. Journal name silver acetylide. Acetylide means C triple bond C bond acetylide. Now, which alkynes will show this test? There is important thing. Which alkynes? Question arises whether all alkynes? No, kids, not all alkynes. If I write down alkyne like this, it will give positive tolerance test definitely. But if I write down alkyne like this, it will not give. If I write down alkene, any alkene, it will not give. If I write down alkane, they will also not give. These will not give positive tolerance test. No tolerance test, because if I react with tolerance reagent, no color means definitely no reaction. No reaction, no color means negative tolerance test. But here one hydrogen is there, so with the tolerance reagent, it will form CH3, C triple bond CAG. It's a white PPT. I hope this is clear to each and everyone, kids. This is clear. Just do let me know in the chat section. Now I will tell you the reason why fructose gives positive tolerance test. I think it's it up to 1 or 115. It will take 1 or 115. I will complete each and everything. Kids, do let me know you got it. I will not take more time, kids. Up to 1 or 115. I will complete each and everything, kids. I hope that everyone is fit and fine with full on energy. Kids, with full on energy, I think everyone, you are with full on energy, kids. Do let me know. You are able to understand each and everything, kids. Is it clear to each and everyone, kids? Do let me know. Very good, kids. Now see. Why fructose gives positive tolerance test? Question, there is question. Why fructose give positive tolerance test? Dollar question, kids, isn't it? Even though it is ketone, even though it is ketone, right? Then why it is going to give this test? Now see, kids, the reason for this question, just see the reason of this question. I think everyone is interested, isn't it? Everyone is interested. See, kids, it's your fructose and let me take this part as R, not required. Now tolerance reagent means you will provide basic medium, right? Now this hydrogen 1, 2, 3, it will transfer to third oxygen, means this oxygen atom Y, kids, and this double bond will go in between 1 and 2. This process, you know, known as tautomerization. Have you studied tautomerization? Yes, kids, I only taught you. Tautomerization will take place, and see, it will convert it into CH OH, double bond C, OH, R. This is known as indiol. Indiol. Now 1, 2, 3. This hydrogen will move from here to here. Double bond will go in between 1 and 2. But once this hydrogen is coming to this carbon is sp2 hybridized. So this will come from this side also and it will come from this side also. Two ways it will come. So you will get two types of compound CHO, CHOHR plus CHO, CHOHR. One is glucose, one is mannose. Now kids, actually once again the tautomerization has taken place. Two times tautomerization took place. Right kids? Now my dear friends, this is not actually the fructose who has given this test, because this is ketohexose and ketones can't give. Ketohexose actually got first converted into aldohexose. And these aldohexose, they have actually given this test, aldohexose. The whole process is known as Lowry de Bruijn van Akenstin rearrangement. Akenstin rearrangement. This very long name, Lowry de Bruijn van Akenstin rearrangement. Kids, you got it? Everyone got it? Oh my god, kids. Everyone, just to let me know. Kids, you got tired? I'm teaching really great things and I think you got tired, kids. Have you got tired, kids? Kids, you got tired? No messages I can see. I can't see the messages, kids. Got it, Nityashree, Hero Brian, that's fantastic. Everyone, you got it? Just to let me know, kids. Everyone got it or not? Do let me know, kids. Wow, Technoblade, that's really fantastic. That's so awesome. That's so awesome. Wow, great, great, great. Fantabulous. Nitishan, Rathesh, wow. Story boy, star boy. Okay, now kids, that's really fantastic. Now this is all about tolerance test. Now let me tell you phalanx test. So tolerance test completed, kids. Now let me move towards phalanx test. Now what is phalanx reagent? First of all, the question arises, what is phalanx reagent? Phalanx reagent is what? Let's see, kids. Phalanx reagent. So, do you know what is phalanx reagent, kids? Any idea about phalanx reagent to any one of you? Just to let me know, kids. Any idea about phalanx reagent? What is phalanx reagent? So, it is an equimolar solution of what happened to AC? Let me check, kids. its equimolar solution of phalanx A and phalanx B. Now what is phalanx A and what is phalanx B? Phalanx A is aqueous CuSO4 dot 5 times H2O. You know very well blue vitriol. You know very well blue vitriol. Blue vitriol. And phalanx B is alkaline sodium potassium tartrate. People call it Rossel salt. You must have heard the name Rossel salt. Have you heard the name, kids? Rossel salt. Now when phalanx A and phalanx B are combining, they will form what? CuOH whole twice. That will convert into CuO, and now what it will do? See what it will do. Now the next page, let me tell you. Sodium potassium tartrate is like this: COONA, CHOH, CHOH, COOK, means made from tartaric acid. This is sodium potassium tartrate. Now CuO will combine like this and the water will eliminate out from here. Then you will get what? You will get compound like Cu, O, H, COONA, COOK. Now this is the complex formed. Now this complex, you can consider it like in this way. You will see in your copy or notes will be given like this: Cu NH3 whole 4 SO4. Some teachers will write like this, or some teachers will write it like this: CuNH3 whole 4 OH whole twice, and some teachers will write like this: CuNH3 whole 4 2 plus. This is most studied example, Huggins et al. If you know sp2d or dsp2 hybridization, coordination chemistry. So in everything, the whole thing is that we are having cupric Cu2 plus. Whenever you see Cu2 plus, this is your phalanx reagent. Now what it will do? If you react RCHO, but remember that only aliphatic, not aromatic, only aliphatic. That is very, very important point. Only aliphatic and not aromatic. It's not aromatic. It can't be benzaldehyde. It can't be benzaldehyde. Benzaldehyde will not give this test. Benzaldehyde will never get this test. Now why? I will let you know why. But first let me write down CuNH3 whole 4 2 plus basic medium. you will get RCOO negative, and this cupric will convert into red color cuprous oxide. Remember that. Cuprous, Cu2O, not right, CuO, cuprous. Red or reddish brown. Remember that. Either red or reddish brown. Cuprous oxide, because it is Cu2 plus at this place. It is not having any color. This is Cu2 plus. Will gain one electron. After taking or gaining one electron, it will convert into Cu single plus or Cu2 2 plus, Cu2 2 plus or Cu single plus. Cuprous oxide. Remember that cupric will convert into cuprous. So this is Falling's test, and benzaldehyde will not give. See why, kids? Why? If I ask you that there is Ag plus and there is Cu2 plus, who is more costly? If I say one electron given to this, it will convert into Cu plus. One electron given to this will become Ag. Out of Ag and copper, who is more costly? Do let me know who is more costly. Who is costlier? Then remember that silver is costlier. More price, more costly. Why more costly, kids? It's only because of silver don't want to undergo oxidation, or its standard reduction potential value SRP is high and its SRP is low. Standard reduction potential is less. So who is having more power to undergo reduction? This Ag plus is having more power to undergo reduction. Can easily snatch electrons. So it can snatch electron, from aliphatic as well as aromatic aldehydes. It cannot snatch. It cannot snatch. This is the only difference in between Tollens test and Falling's test. Till now it's clear to each and everyone. Let me see in the chat section what you're writing, kids. Yes, kids. Good morning. Oh, good morning. Good morning, kids. Show us some fire in the chat section. Kids, only one more hour we need. We will complete each and everything. You can see we are covering each and everything. Most important thing, all the most important things. The heart of these chapters, the most important topics we are dealing with, kids, isn't it? Kids, good morning, good morning, good morning, everyone. Very, very Balu, very, very Herobrine, very, very good morning, Sunny, Nitisha, Malya Varshini. Very, very good morning, Nityashri, everyone. Kids, let's wake up, wake up, wake up, kids, wake up. Wake up, kids, wake up. Everyone just wake up. I'm doing fantastic, I'm great. Everything is moving in the right direction, kids. Now, let's see, kids, let's see. Now, my dear friends, oh, I have written Benedict's. Okay, no problem. Tollens, Falling's, Benedict's. Benedict's also same like, let me tell you what's the difference in between Benedict's and Falling's. Okay, let me show you the difference. Only the difference is, only one difference is here. Only one difference. Only one difference. That phalanx B is sodium potassium tartrate, whereas Benedict's B is sodium potassium citrate. This is the only difference, kids. This is the only difference. Otherwise, the compounds, the color, the attacking agent, everything is same. Everything is same. Otherwise, the compounds, the color, the attacking agent, each and everything is same. Each and everything is same. Each and everything is same, kids, right? Now, before moving towards Skip's test, let me tell you, kids, otherwise you will forget in the examination, that if I talk about benzaldehyde, this is going to be the hero or villain of your examination. What is the name? Mercedes-Benz. Do you remember Mercedes-Benz? Benzaldehyde. Benzaldehyde. Let's suppose this is a player, Mr. Benz. Benton Benz. Oh, Mr. Benz. Oh, how to make Mr. Benz? Mr. Benz can play TT, cannot play football, cannot play badminton, can't play badminton. What do you mean by TT? Tollens test. Will give Tollens test, will not give phalanx test, will not give Benedict's test. Mr. Benz. Right? Trick. It's okay. The trick is good. Why? Mr. Benz is in the jal. Jal means water and got dehyde. Mr. Benzal got dehyde, and under the water he can play indoor game, that is TT. Can't play badminton, can't play football. I think it's clear, kids, right? Now, Skip's test. Aldehydes on reaction with Skip's reagent. What is Skip's reagent? A lot of people, they are getting confused in between Skip's reagent and Skip's base. This is Skip's reagent. Skip's reagent is rosa-aniline hydrochloride. Rosa-aniline hydrochloride. This gives, or say, restores pink color. Restores pink color. What do you mean by restores pink color? Pink color will appear for short time, appears for short time, then appears permanently. So frankly speaking, pink color appears. So these are the Tollens Phalanx Benedict's test. Kids, everyone got it? Okay, kids, let's take a break for 15 minutes, and it's 12:12. So let's meet at 12:30, kids. Okay, let's meet at, just boost up, just take care. Let's take a break and let's meet at 12:30. Okay, kids, and try to get energy. Try to get energy in that break. Okay, kids, will you? Let's meet at 12:30, right, kids? Come with full on energy. 12:30 what? AM or PM? So 12:30 AM. Right, kids? Right. Let's take a short break and let's meet after the break. Okay, kids? Kids, do let me know. Can you hear me? Can you see me? Let's go. Show me some fire in the chat section if you can hear me, if you can see me. Oh, it's over here. Now, kids, do let me know. Can you hear me? Can you see me? I want to see fire in the chat section that if you can hear me, can see me, kids. Now, let's move with the another reaction, name reaction, which is very, very important, kids. Very, very important. Okay. Now, let me show you something, that reactions of aldehyde and ketones. Nucleophilic addition reaction of aldehyde and ketones. Remember that if I talk about NAR, nucleophilic addition reactions, it's wow, yes, everyone is there. Nucleophilic addition reactions of aldehyde and ketones. Just see, kids. If I draw one aldehyde, this is one plane. If I consider this to be the plane, just see. Without this 3D diagram, you won't be able to understand anything, right? What is this, sir? What you have drawn? This is not looking good. Sorry, kids. Oh, I think it will be fit and fine. Okay, now see, kids. If I draw, this is carbonyl group. One valency is coming towards observer side. This is coming towards observer side. If I say this is R1 and this is going away from observer R2, and this is pi bond, let me draw this pi bond like this, going above the plane and going below the plane. Can you see, kids? This is the pi bond, this pi bond only I have drawn over here. This is the pi bond going above the plane and below the plane. Can you see it? Can you visualize the 3D diagram? And if I want to say this is carbon atom having delta positive, this is having oxygen delta negative. Now, this is the electrophilic part. Now, the coming nucleophile which is attached with electrophile, this nucleophile will come from above the plane and will come from below the plane. Kids, are you getting my point? This nucleophile, for making its attack, this will come from above the plane and it will come from below the plane at exactly 87 degree, because here negative charge, there will be electron repulsion. So it will come slightly perpendicular, 87 degree, right? But whatever the part will attack from the upside, same part will attack from downside. So it is Britannia 50-50, 50-50, equal attack from both the sides. And then what you are going to get? You will get compound like CR1, R1, R2, O negative, and this Nu. Nu will be the part. Now see, kids, remember that if R1 and R2 are different, then this carbon will become chiral. Remember that this carbon will become chiral if R1 is not equal to R2 and the attack is 50-50. So we will get equal amount of positive and negative, that is dextro and levo will be in same amount. And this is the intermediate. This is the intermediate tetrahedral intermediate. Tetrahedral Hedral intermediate. Tetrahedral intermediate, and because this is stable having 8 electrons, this is negative charge, so this is the slowest step, and RDS and reversible kids. I hope this much is clear. If clear, then do let me know so that I can move ahead, kids. Yeah, stereochemistry, this is the stereochemistry, kids. Just do let me know everything is perfect, kids. Do let me know, is everything perfect? Is it fit and fine, kids? Do let me know, everyone. Tetrahedral intermediate. So you see, kids, after some time it will form the bond with E, fastest step. This will form the bond with E plus, that is going to be the fast step. So finally you will get C R1 coming towards observer side, R2 going away from observer, NU and OE 50-50, 50% dextro plus 50% levo. Britannia 50-50 you got. Now see, kids, remember that rate of nucleophilic addition reaction is directly proportional to what? Positive charge magnitude on carbonyl carbon and inversely proportional to steric hindrance on carbonyl carbon So one is electronic factor, the other one is electronic factor, and the lower one is steric factor. I hope this is clear to all of you. And in the light of this, let me draw the reactivity order. That formaldehyde, the smallest member of this family, is being gaseous, most reactive. Then is acetaldehyde. Then is acetone. Then it is benzaldehyde. Or acetophenone. This is the reactivity order, and you should know this reactivity order because the whole reactions now, nucleophilic addition reactions, will be based on this. Kids, are you getting my point? Now let me tell you why. Let me explain it. Kids, just see. This is plus charge. Hydrogen is neither donating nor withdrawing electron. This is plus charge. Methyl is donating electrons, so charge decreased, one much stability increased. Two methyls, they are donating electrons, so charge decreased, too much stability increased, too much. Now this is donating through plus I, and this is doing resonance with the benzene, so charge decreased very highly, and steric hindrance is increasing on that way. Charge decreasing, steric hindrance increasing. Least charge, maximum steric hindrance. So least reactive. And this is maximum charge, least steric hindrance, so maximum reactive, and 40% aqueous solution is known as what? Formalin. Formalin, the biological specimen, they are preserved under this category only. This is most reactive. Kids, are you getting my point? Everyone just to let me know, show me some fire and yeah, green hearts. Very good kids, very good. You are able to understand. You are my kids. You are superb kids, superb. Just I will take few more minutes. Kids, I will complete each and everything. I will let you know each and everything. I will not leave even a single stone to be unturned, kids. Just show consistency. Now, this is a rate of nucleophilic addition reaction. Now, I will tell you reaction with hydrogen cyanide, reaction with sodium bisulfide. Grignard reagent already we have done in alcohols, right? So, see, kids. See, kids. Reaction with hydrogen cyanide. Reaction with hydrogen cyanide. If I take acetaldehyde, just see how to frame out the reaction. No need to cram. Hydrogen cyanide. Now, hydrogen cyanide is weak acid. So, you need NaOH as the catalyst. This is known as acidic catalyst. This will break into OH negative and it will take away its proton like this. So, now you see the Cn which was having partial negative charge, there will be complete negative charge, and complete negative charge means more negative charge. So, nucleophilicity increased, and nucleophilicity increased means rate of reaction increased, rate increased. Now, it will attack on this carbonyl carbon from both the sides. It will attack from downside, it will attack from upside. Britannia 50% from front side, 50% from back side. So, what you will get? You will get CH3, CHO negative and cyanide, because you know very well this and this they are not same. So, this carbon is chiral. Chiral carbon means what, kids? I've told you 50% dextro, 50% levo, and now the H plus will attack on oxygen very fast. So, you will get CH3, CHOH, CN, 50% dextro and 50% levo. Both the two forms you will get, kids. This is chiral carbon and this is known as acetaldehyde cyanohydrin. Acetaldehyde cyanohydrin, kids. Its name is acetaldehyde cyanohydrin. Now, acetaldehyde cyanohydrin is known as synthetic intermediate because it is not stable. So, on reaction with water in acidic medium, it will convert into CH3, CHOH, COOH, and this compound you know very well, lactic acid, lactic acid. So, 50% dextro, 50% levo. So, racemic mixture you got, racemic mixture, racemic mixture. Now, see, kids, this is synthetic intermediate. Why it is known as synthetic intermediate? Let me tell you. Why CH3 CHOH CN is known as synthetic intermediate because it is made by man. God has not made it. Synthetic intermediate. We have done hydrolysis. So hydrolysis in acidic medium, cyanide got changed to COH. So we got lactic acid. If we would have treated with H2O2 OH negative, we must have got CH3 CHOH CONH2. Now if we have treated it with zinc amalgam, ethyl alcohol ETOH, known as Mendius reduction, we would have got CH3 CHOH CH2NH2. That's why this is known as synthetic intermediate, because number of products you can prepare from this, number of products. Now see, my dear students, if the same reaction would have carried out with benzaldehyde, tell me what you will get. Any idea? Question is, they will give you question like this: benzaldehyde, hydrogen cyanide, followed by hydrolysis in presence of zinc. The product's name will be what? So the answer is gets, first you will get benzaldehyde cyanohydrin, CHOHCN. Now on hydrolysis in presence of zinc and water, you will get this cyanide will convert into, this got 50% dextrolivo. So you will get 50% dextrolivo, CHOHCOOH, 50% dextro, 50% levo, and this name is Mendelic acid, father of genetics. He has given independent assortment of genes 9 raised to 3 raised to 3 raised to 1. You know very well, bio students. You know very well. Pisum sativum. Okay, Now kids, another reaction of aldehyde and ketones with sodium bisulfite test. Sodium bisulfite test. Now kids, all reactive aldehyde, all reactive smaller aldehydes and few smaller ketones, smaller aliphatic ketones on reaction with NaHSO3 give white PPT. Remember that color matters a lot. White PPT. White PPT. And remember that higher aldehyde and ketones will not give this test. Why, kids? Because they are not reactive. So make a note. Higher members are less reactive. so will not show this reaction. And that's why it becomes a very, very good distinguishing test. And that's why it becomes a very, very important, what kids? Distinguishing test. Distinguishing test. Now see kids, what happens and how this reaction will take place and what type of questions can be asked. Are you ready kids? If everyone ready, show me some fire in the chat section. I will show you this test. I want to see some fire in the chat section. Thank you Malaya Varshani, thank you, thank you. Kids, I want to see some fire in the chat section. Wow, Vineet Singh. Ramwan, very good Vineet Singh. Wow. Great compliment, Vineet Singh. Now see kids. Today also I will give you some memory charts kids. Don't worry. I will give you each and everything. Now see how this reaction will take place. Suppose if I am provided with CH3, CH double bond O. You can see very clearly this is negative and this is positive, and if I am going to react with NaHSO3, Na positive, HSO3 negative, now which one will attack on which? Negative. This is positive, that is negative. So this negative part will come and attack on this carbon. So what you will get? You will get compound like this, CH3, CH, SO3H and NaONA. Now kids, this is acid. Acid means will donate its proton. Acid is always famous for donating protons. So this proton will come over here and this Na plus will go over there, exchange offer. This is going to be fast acid base neutralization, so fast. So you will get CH3, CHSO3, Na and OH. That's why it is a white PPT. White PPT. Now how the question will come? How the question will be asked? See, question will be asked like this. Which of the following will not give white PPT, white PPT with sodium bisulfide NaHSO3. Now options are A, acetaldehyde, B, acetone, C, propanol, D, acetophenone. Do let me know what should be an answer. What should be the answer in the chat section. I want to see your answer kids. Let's see who is going to give the correct answer for this question. If you are able to understand whatever I am teaching, you will be able to give the correct answer kids. Do let me know what's the answer. Kids, fast. Acetophenone, very good. D is the correct answer. Acetophenone is the correct answer. Fantastic kids, you got it. You are getting it. Lovely, lovely studies kids. This is highly stable because it is stabilized by resonance. So least reactive. This is the answer. Now, another thing, sodium bisulfite NaHSO3 is also used for purification of compounds. Purification. How we will use it for purification? Let's see. Suppose kids, if somebody wants, somebody like Yo-Yo Honey Singh is having ethyl alcohol, last drink of ethyl alcohol. Now Champa came to his house. Champa, ting ting ting, and Champa added acetaldehyde to this, one last peg. Now is it safe? Alcohol has become impure. Now Yo-Yo Honey Singh started crying. Hey, my last peg was there. You destroyed it. You Champa. He started crying. Now somebody told Yo-Yo Honey Singh, we know Mr. HSP, Baba HSP, he will help you. So he called me. Then I have come to his house and I said, hey, I'm going to add sodium bisulfite, NaHSO3. Now sodium bisulfite loves acetaldehyde. Now sodium bisulfite will react with acetaldehyde, and sodium bisulfite will form what? It will form white PPT, CH3, CHSO3Na, and OH, white PPT. The white PPT will settle down over here. Now who will left in the solution? Only alcohol will left. The situation will be like this. The white PPT will settle down over here and only the alcohol will left. Now you can filter it. Pure alcohol is there. And remember that this white PPT is soluble in mineral acids. So if you add water to this, it is soluble in mineral acids. So it will get separated and I will get back my sodium bisulfite. Now see, everything is separated. Alcohol, acetaldehyde, sodium bisulfite. So this is the purification test. Kids, how was the story? Do let me know in the chat section. Do you like? Did you like it? Yes. Wow, Vineet Singh, that's really fantastic. Kids, do let me know. You are loving this story? Now let's see reaction of aldehyde and ketones with alcohol. Reaction of aldehydes and ketones with alcohol. Thank you, Herobrine, Vineet Singh, Nitya Shri, Shalini. Reaction of aldehyde and ketones with alcohol. Aldehyde plus alcohol in presence of dry HCl. Let's see what is going to happen. Do you think aldehydes, they are going to drink alcohol? Let's see. CH3, CH double bond O plus ROH. Now you know that why HCl is added. HCl will give out proton and this proton will attack to the lone pair of oxygen and it will convert this aldehyde into CH3. Right now it's negative charge and partial positive charge. So once HCl has attacked on this oxygen, oxygen will say, I can't tolerate this positive charge, and it will withdraw this electron. So it will convert it into like this, CH positive, OH. Now there is complete positive charge. There was partial positive charge. Now here is complete. So electrophilicity got increased. So rate will increase automatically. Rate will increase. Now see kids, who will attack where? this RO negative will attack on the plus charge and H plus will attack on the negative part. What you will get, kids? You will get reversible reaction. You will get CH3 is written to the CH3 CHOH OR. This is known as hemiacetal. Remember that, hemiacetal. One more ROH will come. ROH will come. Water will eliminate out. So what you will get? Water will eliminate out. You will get CH3 CHOR acetal. You will get acetal. You got it? How will you find out which is hemiacetal, which is, this is single ether and this is gem ether. Gem ether means diether. Gem ether is acetal. You got it? Now let's see ketones. Ketones are less reactive. So what scientists will do? Scientists have applied one fundamental thing. They have reacted cyclic alcohol, that is OH. Now what is the benefit? I will tell you the benefit, kids. The water will eliminate out in this way. Dry HCl will take reaction in the forward direction. Dilute HCl will make reaction come in the backward direction. Le-Chatelier's principle is valid over here. Now see, kids, CH3 CH2 is not a cyclic ketone. Cyclic ketones are stable than acyclic ketones. Why, kids? There is science. What is the science? First of all, let me tell you that if you add water, Le-Chatelier principle says equilibrium will come in the backward direction. Now, they have used only one type of alcohol. So, one type of this, 1 plus 1, two types of entities on this side. 1 plus 1, two types of entities this side. So delta S change in entropy is means approximately 2 minus 2 is 0, and delta H, pi bond is breaking, 2 new sigma bonds are getting formed. So delta H is negative. Exothermic reaction. So this will make reaction to be feasible, because we know that Gibbs-Helmholtz equation delta G is equal to delta H minus T delta S. So this becomes 0, so this magnitude will be gone and this will be negative. So it is decided by this delta H to be negative. Otherwise, if you are using two alcohols, see, if two alcohols being used, then what is going to happen? CH3, C double bond O, ROH. You are removing water. Then see, 3 moles you are using on this side, CH3, OR plus water. Now this side you are getting 2 types of moles. So change in entropy is what? Delta S here is final 2 minus initial 3 negative. So the reaction is non-spontaneous. Got it, kids? Non-spontaneous. That reaction is non-spontaneous. The thermodynamics is working over here. Thermodynamics, right, kids? You got it. Now, only one thing in aldehyde and ketones is left. I'm going to tell you. Just stay tuned, right? What's that? That is reaction with ammonia and its derivatives. Reaction of aldehyde and ketones with ammonia and derivatives. Reaction of aldehyde and ketones with ammonia and derivatives. So first of all, let me tell you one reaction which is very, very important. Then I will tell you other reaction. First reaction is formaldehyde. Formaldehyde. 6 moles of formaldehyde plus 4 moles of ammonia. This is very, very important reaction because this is the first member which is gas and this is also gas. Both together they will form CH2 whole 6 and 4 hexamethylene tetraamine. Hexamethylene tetraamine. This is also known as, you know very well, urotropine. Urotropine. You must have heard this name, kids. Urotropine. Do let me know. You must have heard the name urotropine. How it look like? Nitrogen, CH2, CH2, nitrogen, nitrogen, CH2, nitrogen. In the middle there is nitrogen. Now nitrogen can't be direct, so nitrogen, CH2, nitrogen, CH2, nitrogen. It's like this. If you see the chair form, nitrogen, nitrogen. So 3 nitrogens are there, 4th nitrogen here. Now nitrogen, CH2, nitrogen, nitrogen, CH2, nitrogen, nitrogen, CH2, nitrogen. This is urotropine. All these are urotropines. This is very, very important reaction. Kids, first of all, do let me know. Only few more minutes I will take, kids, just few more relateds. Just to let me know you are getting it, kids. Everyone, just to let me know you are getting. Are you getting each and everything, kids? Yes, this is not planar. This is chair form, so this is not planar. Chair form can't be planar, kids. Chair form can't be planar. Got it, kids? Now, let me tell you reactions. Rest of the reactions will move like this, in this way. Just see. Any aldehyde or ketone, if you react with NH2Z, water will eliminate out and this will happen in slightly acidic medium. pH is equal to this much and you will get R C double bond N Z plus water. Now let me show you the reactions on the another page. This is first nucleophilic addition, followed by elimination, overall we will say substitution. Overall it's substitution. Now let's see the reactions, how they will move, kids. CH3, CH double bond O. If I react it with ammonia, so water will eliminate out. I will get CH3, CH double bond NH, imine. I will get imine. If I react it with 1 degree amine, RNH2. Now once again the water will eliminate out. I will get CH3, CH double bond NR, imine of 1 degree amine, imine of 1 degree amine, also known as skip space, skip space. Now if I react acetaldehyde, this acetaldehyde with hydrazine, let me show you on the next page. Let me show you on the next page. If I react this acetaldehyde with hydrazine, NH2, NH, H, what I will get? Water will eliminate out. I will get compound like CH3, CH double bond N, NH2. Gene will convert into zone. This is hydrazine. Remember that? Hydrazine. It will convert into zone. So its name will be acetaldehyde hydrazone. Everyone say acetaldehyde hydrazone. Gene got converted to zone. Gene got converted to zone. Same if I say that acetaldehyde on reaction with phenylhydrazine, NH2NH, C6H5, then what I will get? CH3, CH double bond NH, C6H5. What should be the name? Acetaldehyde phenylhydrazone. What I will say? Acetaldehyde phenylhydrazone. Gene got converted to zone. Now the most important one I am going to tell you, see to it. Acetaldehyde, if reacting with NH2, NH, C6H5, NO2 and NO2, just see with respect to this 1, 2, 3, 4, 2,4-dinitro, 2,4-dinitro, phenylhydrazine. Now this will react with this to eliminate out water, kids. Water will get eliminated. What you will get, kids? Just see to it what you are going to get. You will get CH3, CH double bond N, NH, C6H5, here NO2, here NO2. Now ROI, remember that ROI, red or orange or yellow colored complex, you will get this compound's color is either red or orange or yellow. This is known as acetaldehyde 2,4-dinitro phenyl hydrazone, and that's why this is very important distinguishing test. This test is given by all aldehyde and ketones. Remember that this test is shown by, this is distinguishing test shown by all aldehyde and ketones. And this is known as Brady's reagent. What it is known as, kids? Brady's reagent. Famous is Brady's reagent. And this test is also known as 2,4-DNP test. 2,4-DNP test. You must have heard this name, 2,4-DNP test. Brady's reagent, 2,4-dinitrophenyl hydrazine. Kids, do let me know. This is very important test. Have you ever heard the name? Have you ever? Just we are going to complete it, kids. It's about to complete. It's about to complete. It's about to complete, kids. It's about to complete. Only 10 minutes more. Only 10 minutes more, kids. 10 more minutes. Just 10 more minutes, kids. Now, reaction with semi-carbazide. Reaction with semi-carbazide. So if I say that I'm going to react acetaldehyde with semi-carbazide. Now what is the formula of semi-carbazide? Because they will not give you semi-carbazide. Now remember that. If you don't know semi-carbazide, you know urea. If you know urea, we can make it. See, NH2 is fixed. And let's add over here urea. What is the formula of urea? NHCO, NH2. This is urea. To NH2 add urea, you will get semi-carbazide. Now see, kids. This nitrogen's lone pair is localized and this nitrogen's lone pair is delocalized. So who can be more nucleophilic? Delocalized are doing resonance, involved in resonance. This is localized, so will attack, will be more nucleophilic. This nitrogen is nucleophilic, more nucleophilic, kids. So this is involved in removal of water. Water will get removed from here and the product you will get like this. They will combine together to form CH3, CH, double bond, N, NH, CO, NH2. Its name is acetaldehyde. Semi-carbazone, semi-carbazone. Now, reaction of aldehyde and ketones with hydroxylamine. Suppose if I say that I'm treating this acetaldehyde with hydroxylamine. What is hydroxylamine? NH2OH. Water will eliminate out. Now you will get CH3, CH double bond NOH. Either I can call it acetaldoxime or I can say oxime of acetaldehyde. Now this compound will show GI. I have told you in GI it will exist in two forms. Syn and T. What is the relation? They are GI of each other. Kids, you got this much. Now the PCC, strong oxidizing agent, mild oxidizing agent, all these things I taught you in alcohol. Now do let me know in the chat section. Till now everything is fit and fine. Technoblade is saying brain is not working. Just give me 10 minutes more. Last 10 minutes. Technoblade, last 10 minutes and the session will get over. Last 10 minutes. Just 10 minutes. Just 10 minutes. Technoblade, last 10 minutes. Not more than that. Okay. Now kids, naming reactions we have done. All the name reactions of aldehyde and ketones we have done. Ilamethi, good morning, good morning. Now kids, I think I have told you all the name. What happened? How this name reaction is coming? How this name reaction is coming, kids? Okay. Now kids, do let me know everything is clear. Is everything clear, kids? Just to let me know. Now, after this, all the name reactions I have told you of aldehyde and ketones, all the tests I have told you, I have to tell you one name reaction, that is Riemer-Tiemann. Last name reaction, last name reaction, that is Riemer-Tiemann reaction. Okay. Now see kids, if I want to prepare aromatic aldehydes, one way is Itard reaction. This is name reaction. Its name is what? Itard reaction. What it will do, kids? It's very, very important, Itard reaction. What it is going to prepare, just see. It converts toluene. It converts toluene to benzaldehyde. Toluene to benzaldehyde when treated with chromyl chloride, CrO2 Cl2. It is known as chromyl chloride. Chromyl chloride is red vapors, red color vapors, CrO2 Cl2, red vapors, CCl4. You will get one intermediate. That intermediate is like this. Ochro, Hasletu, Dobara. This is the intermediate. Unstable, This on hydrolysis will give you benzaldehyde, remember that single step conversion of toluene to benzaldehyde. This is known as Itard reaction, very important, Itard reaction. Another reaction is Reamer-Tiemann reaction, kids. What's the name? Reamer-Tiemann reaction. What's the name, kids? Reamer-Tiemann reaction, RTR. Reamer-Tiemann reaction. What happens in this reaction, kids? Let's see. That phenol reacts with CHCl3, KOH. You will get salicylaldehyde. KCl plus water. Its name is salicylaldehyde. Or orthohydroxybenzaldehyde. Now, if you have treated it with what? Phenol plus CCl4, KOH, you will get salicylic acid, OH, COOH. Now kids, this salicylic acid is very important. This salicylic acid holds a hell lot of weightage. Let me tell you why it is important. See kids, OH COOH, if you treat it with acetic anhydride or acetyl chloride, CH3 COCl, this is acid derivative acetyl chloride. This acetyl chloride is what? Acid derivative, so it will not react with acid, it will react with this phenol and its HCl will eliminate out. Then what you will get, kids? This COH will remain over here, this O at this place, and you will get COCH3. Its name is acetyl salicylic acid. This is known as aspirin, the painkiller and blood thinner, and that's why it saves us from heart attack. The same product you could have got from acetic anhydride also. OH, COOH, when reacts with acetic anhydride, then what will happen, kids? This H will react with this, will eliminate out acetic acid, and this part will attack, and you will get same aspirin, OCO, CH3COOH. Now, the same type of reaction you will get in the examination when you react this compound with methyl alcohol, but compound will be different, see, and maximum people will get confused. OH, COOH, if I react it with methyl alcohol, now methyl alcohol is alcohol, will not react with OH, it will react with acid, and whenever acid reacts with alcohol, acid will lose its OH, and the product will be OH, C double bond O, OCH3. Its name is methyl salicylate. Methyl salicylate, kids. This is known as oil of wintergreen. Oil of wintergreen. Kids, everyone got it? Just to let me know, everyone got it? Wolff-Kishner reduction I have told you in alkanes. Wolff-Kishner reduction, Clemenson's reduction, this thing I have told you in hydrocarbons. Already I taught you. Now, only one thing is left, the mechanism of Reamer-Teamer. 3 minutes more, just to tell you the mechanism of Reamer-Teamer. That's all, kids. Mechanism of Reamer-Teamer. Kids, now see, am I audible and visible? Kids, I was unable to see your chats. Now see, now check. Hello. How much time has happened that I was not audible? Just to let me know in the chat section. Now check. Am I audible and visible, kids? Now check. Now check, kids. Am I audible and visible now? Kids, do let me know. Am I audible and visible? For how many minutes I was not audible and visible? For how many minutes I was not audible and visible, kids? Do let me know in the chat section. For how many minutes I was not audible and visible, kids? For how many? Oh, about 10 minutes. So should I tell you mechanism once again, or is it okay, kids? Should I let you know mechanism once again, or is it okay, kids? Should I tell you mechanism once again? Kids, okay, let me repeat the mechanism. Let me repeat the mechanism. So from here, see, it's already written. I'm going to repeat it. See, mechanism of RTR. This is the reaction, salicylaldehyde. KOH will break. K positive, OH negative is strong base. It's being a strong base, so it will break to give K positive and OH negative because this bond was ionic bond. It will break because it was ionic bond. Now OH negative will attack on chloroform. So this is acid. It has attacked. Acid base neutralization has taken place. You got negative charge. Now negative charge will do back bonding with 3D vacant orbitals. It will do back bonding. BB for back bonding. Now this carbon's negative charge is there. K plus will take away this chloride, so it will form dichlorocarbene. What is the name of this intermediate? Dichlorocarbene. What is the name? Dichlorocarbene. Actual intermediate electrophile, only 6 electrons, neutral electrophile. Now this page is clear, kids? Is this page clear? Do let me know in the chat section. Is this page clear, kids? Oh, it was covered up in alcohol, phenol and ethers. Oh. Now kids, this page is clear. No problem. Once again, let me tell you. Is it clear, kids? This page is clear. Do let me know, kids. Now the next page. This OH negative will attack on phenol also. That's why it is known as carbolic acid. Acid base neutralization will take place and it will become phenoxide. Till now it is aromatic, but see here it has attacked. This is 6 electrons, this is 8 electron. It has donated 1 electron. After donating, its negative charge will go and that negative charge will transfer to that carbon. Now this hydrogen is allylic hydrogen. While leaving its electrons, It will move to adjacent carbon. Now this electron will come to this place to make it aromatic. Right now it is not aromatic. Once it will come over here, it will become aromatic. 6 pi electrons. It is planar, aromatic. Aromaticity is gained. Now 2 OH, 2 hydroxyl groups are not stable on single carbon. So water will eliminate out, and in this way marriage got completed. You got salicylaldehyde. Got it, kids? Now completed each and everything. I've told you each and everything, kids. Dhanyawadalu. Good night. Bye to all of you. Good morning. Khuda Hafiz. Sayonara. Bye to each and everyone. Very good, Vinit Singh. Very good. It's Kriko. Thank you. Hariwala. Thank you. Thank you, everyone, kids. Thank you. Thanks a lot. Thanks a lot. Bye bye. Good night. God bless you, kids. May Almighty God bless you with all happiness and prosperity. Everyone, bye, kids. Herobrine, Balu, Roshan, Unknown, Nityashri, Hariwala, Vinit Singh, it's Kriko, Nityashri, Riya Desai. Thank you. Good night. Good night. Good night. Good night. Good night. Malaya Varshini. Thank you. Thank you. Thank you. Good night. Good